Welcome to this second telemetry and data workshops, which is organized by the activity, the work package Network Technologies and Service Development from the GÉANT GN4-3 project. And I will now give the floor to Mauro Campanella, who will make the introduction and also will chair our first session, which is a traditional and streaming telemetry. Mauro, the floor is yours. So you can start, Mauro, sorry.
No, I suggest we start immediately to the first presentation about streaming telemetry.
That's me, I guess. Huh?
Yes, please.
Let me share my screen, if I still know how. I wanted to give a somewhat short presentation on our experiences with streaming telemetry inside SURF, and maybe a little bit of lessons learned and what we're still working on. The end goal is to do it as a drop-in replacement for the traditional SNMP monitoring. A little bit about me. I work for SURF, the Dutch NREN in the Netherlands. I'm technical product manager for the service layer, and I'm somewhat obsessed with metrics. I like to see, besides the obvious usage of telemetry, I like to see that I get a lot of pleasure out of seeing that the network is actually being used. And that's how I got to work on the whole measurement setup at SURF. What I wanted to talk about is a little bit about the SURF network in metrics, our current measurement setup, and why we want to go to streaming, and then I'll go on to our first experiences with the streaming telemetry at scale, in our network, and the work that still has to be done to eventually replace it as a entirely move away from SNMP entirely, what we're still going to need. Well, the SURF network, the current version of our network started rollout in 2019. And the last customer service was migrated on December of 2020. The network is fully automated and orchestrated from the router config to the CMDB. Currently, we have about 433 devices. That's fairly specific. It's entirely Juniper-based. Traffic levels on IP are currently about 300 gigabits at peak moments, and for our layer 2 services, that's about 340 gig. So that's our network. Of course, we have to measure that. We measure all our services, and we have a whole measurement infrastructure running on that. All our metrics are eventually stored in an InfluxDB database. We have an enterprise version of that. We currently we collect everything by SNMP through a telegraph. That's also from Influx data. We use capacitor to do all sorts of metric transformations, aggregate metrics, and stuff like that. And Telegraph also extracts a lot of metadata that's stored in descriptions and stuff like that to make it queryable by service. So we can query the database by what we call a subscription ID. That's basically service ID. And instance ID, that's an instance of a service, maybe the primary or the secondary IP config of a customer. And also if it's what service type it is, EVPN, customer IP, or external IP connectivity. And in the end, all data is directly queryable by these tags, by this metadata. The setup is fully automated, so we don't usually experience any issues with consistency or errors that are created by administrators or stuff like that. So it's fairly accurate, but it's still SNMP based. And why that's a problem, we'll get into that. And then I'll go on to our experiments with streaming telemetry at scale. But why do we want streaming telemetry? Well, SNMP is the polling mechanism is inefficient. SNMP is especially inefficient, so it creates a lot of load on our network elements. And we had a lot of problems with that in the past with our older routers and our older switches that were just not up to the task of polling every minute. And also as a result of that, the resolution of your measurements is fairly low. We currently poll at 1 run per minute. So that gives a measurement of every minute. And then when we started the rollout of our new Juniper network, we had the possibility of doing streaming telemetry. And what is streaming telemetry? What's the benefit of it? It has a focus on metrics, statistic metrics, and all that good stuff. It's highly structured, so it makes it fairly efficient to process the data. And because the data is pushed out every interval by the network element itself, it makes it efficient. And it also makes it possible to get a high resolution of metrics. With our current Junipers, it's up to every second, and maybe even higher, I don't know. And another benefit of streaming telemetry, it's not just the traffic. You can also stream any type of metric like BGP updates or stuff like that, or even event based data. Well, we had our first setup with streaming telemetry was the native GTI. That was the only thing available at the time. In 2019 or 2018, we started building, and it has a lot of benefits. It's easy to deploy. It's just a few lines of config in the router, in each router, and then it starts UDP streaming all kinds of metrics towards an IP address. Because it comes directly from the FPCs in the routers, it basically doesn't have any extra load on the devices. We started with a setup. All the data was collected by FluentD. It has a plugin for streaming telemetry from Juniper. It transforms that data into an InfluxDB stream, and then pushes it on to InfluxDB, which then stores the metrics. FluentD also has the possibility to export to Logstash or other time series databases. But as time went on, we deployed more and more routers. It became a little bit like this, like drinking water from a fire hose. We ended up with 400 plus network elements emitting streaming telemetry. So we quickly started running into scaling issues. FluentD is based on Ruby, and it's a single-threaded process. So we using multiple instances of FluentD behind the UDP load balancer. And even though we never got it really stable with FluentD, sometimes it just was too much and it crashed. And another reason to not do this is the plugin project for FluentD seems abandoned at the moment. So yeah, we started to looking at other possibilities. It's also possible to do this native GTI with Logstash, and but I haven't tested that. Telegraph. Somebody started making a plugin for Telegraph for the native GTI, but it never ended up in the final code base of Telegraph. So so we never did that. Juniper also has another way. It basically has two ways of doing streaming telemetry, and the first one was the proprietary option. This is based on OpenConfig. We just started that this week, so I don't have a lot to tell about that. What I can tell you is we waited to start this until our upgrade to Junos at least 19.1, because before that you had to install packages on every router, so we didn't want to do that. So we're currently running at 19.3, so we have just built-in OpenConfig telemetry possibilities. Another advantage of using the OpenConfig variant is we could use Telegraph. Telegraph is highly plugin driven, and there's an OpenConfig GTI plugin that is currently being maintained. Telegraph is also written in Go, and it has more multi-threading possibilities. So we, in theory, can scale better. Also, the OpenConfig variant is, in my eyes, is more future-proof, less proprietary. It's open standard based. I even, in the first testing, I even used the GNMI plugin from Telegraph. That's basically for the Cisco routers. It just worked. Also, the OpenConfig GTI has more sensors, and you can also create your custom sensors with the netconf proxy functionality in JunoS. Well, as I said, we have done a little bit of testing with this. Telegraph is multi-threaded, as I said, if you can configure it correctly. And we're still working on that, where the sweet spots are. And we currently run into that flushing the metrics to InfluxDB is becoming the bottleneck. So, and that the bottleneck is in Telegraph itself. So it's not InfluxDB, but in Telegraph. So we have to tune that. So we're still very much in the process of tuning and scaling that up. And all this testing is done with the 1 measurements per second. Maybe you don't. If you don't. If you still do maybe 1 measurement per 60 seconds or 1 measurement per minute, you won't have these scaling issues. But we wanted to do a high resolution. So, but basically, for this, the jury's still out on how easy it is to scale with Telegraph. So yeah, maybe in the 3rd edition of the workshop, I can tell you more. But with if you do it at a lower resolution, in theory, it's possible to do this in production as a drop-in replacement for SNMP. But yeah, why don't we do it? Why don't we use it in production yet at low resolution? Well, in the way we designed our network, or designed our services and stuff like that, we are heavily dependent on what's in the description of an interface. So currently, every interface and every service has a description. And when a metric comes into Telegraph, we extract all the metadata in that description, and it's stored as separate tags into the database, so we can use that to relate every metric to a customer service or a service in general. But at least Junos, I haven't tested with Cisco or any other vendors, but Junos emits the telemetry in a hierarchical structure. Every level in that hierarchy is emitted as a separate set of metrics. So in the right, you see that hierarchy. You have the interface, the state, and under the state you have a lot of metrics like the type, MTU, name of the interface, description, the operational state, and all that kind of stuff. And in another hierarchy, you have the counters, like the incoming octets and packets and stuff like that, the stuff we're really interested in. As you can see, you don't have anything like a description in that counters hierarchy. So we can't. So we can only query the data by interface and device, and then you get the correct metrics. But we can't query the data at the moment through the description. And this, at least in InfluxDB, makes it impossible to query a packet by the description or the data that's in the description. So the next thing we are going to look into is, as I said, Telegraph has a lot of plugins, and it's completely plugin driven. There's also something called an aggregator plugin, but the plugins that currently exist do not have the functionality to aggregate metrics based on a subset of tags like timestamp, device, or interface name, so that we can combine two metrics into one metric with all the data in it. And I think the next step for us is going to be to find, because I'm not a developer, to find a developer inside Surf or maybe somewhere else that can help us develop such a plugin. Telegraph is open source, so we could easily fit that into that to the software. And that's it for me and this presentation.
Thank you very much, Max.
Any questions?
If there are some burning questions, and then we may have also some time at the end of the free presentation of this hour to combine the questions. Any burning question, please unmute and make the question.
I think it'd be good to discuss things once you've heard all three talks, maybe.
Yeah, I would prefer that, and indeed. Thanks a lot. Very interesting talk, actually. A lot of interesting issues on the table to discuss, which are common to many things we will see today. I suggest that Keith starts the talk about area of the life of Brian in the GÉANT backbone. Please, Keith, the floor is yours.
Morning, everybody. Find my presentation. You'll have to bear with me today. I'm currently in a COVID positive house, and although I haven't tested positive yet, I'm rapidly going downhill. So my brain's a little bit fuzzy. I think quite a lot of you on this call. So yeah, Keith Slater, Senior Service Manager in GÉANT. I've been at GÉANT for about 5 years now. I'm also the product owner of Brian. And so what is Brian? Well, it's a good example of asking technical people to name things. They come up with a name like Brian. It stands for Backbone Router Interface Analysis. And it's essentially a suite of tools. It's got a Grafana front end, as you can see here. Visualizes network utilization based on SNMP. It doesn't seem too dissimilar from what Max just presented. Lots of the parts of the tools are similar, and like SURF, it's largely automated. If the interface description is correct and the inventory is populated correctly, all the panels and the dashboards are created automatically, which our implementation team certainly like. There are exceptions to this. We poll third-party devices, NREN routers, and so we have to build those manually. Now, I've given quite a few presentations on what Brian is, so I'm not going to go into any detail. I did give a presentation at TNC last year with Eric Reed, who is the architect of Brian. I'll post a link to that in the chat after this. It's the Tuesday session, imaginatively called Life of Brian. And yeah, it's about an hour and a half long. So if you are interested, you can see more there. So what have we done in the last year? Well, we've created 2 different views of Brian. There is a public view, which is a slightly cut down version. And then there's the full view that we give to NRENs. They can log in using single sign-on. There is a little bit more needed in the back end than just having a single sign-on login. So if anybody does need that, they would need to also send a mail to help@géant.org to get that set up. We've added clustered InfluxDB, so that's now a paid for enterprise version of InfluxDB, so hopefully all our data is safe. We've created standard dashboards for NRENs and certain products. So what I mean by that is, rather than having a different view on each dashboard, we use exactly the same view. It's just easier for repetition. If software development, just use the same template for all the dashboards. As I said, we've added external data sources. So for those NRENs that have direct GWS, so where they take GWS product directly from suppliers, we then poll their routers using a mixture of MIBs and direct OIDs. It's for reporting purposes, really, so that when the supplier sends us a bill, we can have a quick check to make sure that what they're billing us for is actually somewhere similar to the traffic that we see. We've added DSCP32 counters and destination class usage. So our upstreams, all the packets from our upstreams, we tag with DSCP32. That enables us to both count those packets for the graphing of NREN in direct GWS, and it also means that those NRENs are also able to differentiate between the peering traffic and the GWS traffic. We've added multicast, so we now have graphs for the EU METSAT multicast stuff. We've added errors and discards. It was actually quite hard to find a dashboard with any discards to test that, but we did find one eventually, so we know that that's working. We've added new dashboards for various products, Copernicus, the new 10 gig guaranteed bandwidth service, the replacement for the 10 gig Lambda. One of the main points of bringing in Brian was to get rid of our antiquated version of cacti. We believe that we are now graphing everything that was in cacti. Some of the back-end data of cacti was being used for reporting. Most of those reports have now gone over to InfluxDB. I think there's only one more report, and that's MDVPN. And then hopefully, fingers crossed, we can finally turn off cacti. And then we introduced third-party access to InfluxDB. So we had a couple of requests from various projects to access some of the data InfluxDB. So we created another InfluxDB instance, which again, we called Robin, which is read-only Brian instance. And yeah, some third parties are now looking at that data. The next few slides are regarding the Brian architecture. These are exactly the same slides that I have presented several times last summer. I think it was one of these workshops, STF and TNC. So I'm not going to go through these in detail, but you can see lots of the components are similar to SURF. We use Telegraph, we use Capacitor, we also use Monica. Inventory Provider is a home built tool. This goes into what those components actually do and the principles of Brian. What we're going to do in future releases, well, we still have a lot of old data in Cacti. One of our very skillful software engineers has created a tool to import that data from the RRD of Cacti into Brian. It's going to be a fairly painful process, but once we've imported that data and then got the MDVPN reporting into InfluxDB, hopefully then we can turn off Cacti. Recording of historical traffic utilization for a service. So we've recently introduced service IDs. It's just a unique ID for every service that we have on the network. So once that's all rolled out, we will then be able to produce graphs based on a service rather than an interface. So for example, if NREN A moves from 4 times 10 gig to 100 gig, we will continue to graph that service rather than those individual interfaces. So hopefully we should be able to see the data and backdate it with that data in Cacti. We'll assign service IDs to all of that data as well. Moving the capacity planning report into Brian, that will release some resource from our network engineering team. We always have new services coming on board, so we will be releasing new dashboards for those. Introducing alerting, it's kind of a pipe dream. Maybe we will do it, maybe we won't, but it's certainly something that we're going to be looking at. Getting the optical network into Brian, certainly something that's on the roadmap. Availability kind of goes hand in hand with introducing alerting. Yeah, at the moment, our Grafana doesn't deal very well when an interface is still up, but the traffic drops down to 0. So it's something that our development team is looking at. And introducing streaming telemetry, but we've been going through the same kind of challenges that SURF has gone through. So it's really up to Juniper to work with us on getting that working. And that's all I've got to say today, other than here the 2 URLs that you can access Brian with, brian.géant.org and public.brian.géant.org. The second one you can access without a username and password. So I would suggest if you do want to have a look, then that's a good place to start. Thank you very much.
Thank you very much, Keith, also for keeping the time, and all best wishes, by the way.
Thank you.
Given your location.
Yeah.
But I hope really it goes as a bad flu and nothing else.
Yeah, none of it is too bad. Thank you very much.
Thank you. Let's keep the questions to the end of this session. The next speaker is, of course, Tim. Please, Tim.
So yeah, I'll just throw some thoughts in on the 2 approaches we've seen today from Max and Keith about traditional and streaming telemetry, and just show those in the context of a high-speed monitoring example that we did recently with my colleague Raul Lopez. So there are obviously many sources of telemetry data, and those measure and monitor very different properties. We've heard a lot of those already today. Some are based on active measurements, some on passive measurements. Traffic levels are the sort of thing that Brian shows most predominantly, but we've also heard mention today of S flow, net flow, the various performance test results you might want to integrate through tools like perfSONAR. But what I'll focus on here is just a specific example of gathering data from network devices, and in particular just having a look at a couple of examples of the sort of classic polling-based approach with SNMP versus the push-based approach that Max introduced with streaming telemetry. So with the polling approach, we've just seen Brian. I think that's a very good example. There again are the two links that Keith mentioned. And typically what we use that for is to see interface utilization over time, the number of MRTG and other types of plots of that sort of thing. I've probably seen hundreds, if not thousands of those charts over many, many years. And they are very useful for seeing the general traffic levels. Typically, from GISC's point of view, all our members have access to a tool we provide called NetSight that lets them see the detail of the traffic levels over time at their interfaces onto our GÉANT backbone. And that's useful for them. It's also useful for us when we're doing capacity planning. That data is very useful for us to see the trend in traffic growth, so we can have conversations with sites when their capacity gets to a certain level for a certain percentage of the time. That sort of polling, though, is generally periodic and typically at 5-minute intervals. I think Max said Surf do it at 1-minute intervals. But I think Brian is 5 from the examples we saw, and the data therefore is plotted is usually a 5-minute average or sample of that data. You can sample more frequently, as Max said Surf do, but then that has implications for the polling systems and the data retention. So certainly when I was managing the university enterprise network, it was a consideration for us that with the number of devices we had and the polling tools, you had to go around each device and poll them from one point, and that just physically took a certain amount of time, and obviously did place a load on the devices. And of course, the more frequently you get data, the more data you have, and therefore you've got the issue of storage and retaining the data. With the streaming telemetry, as Max explained, you're streaming the data pretty much continuously from the device. You configure the device with what you want to send, where it's going to, frequency, and this effectively provides a real-time stream of information, a very fine level of detail of what's happening with the device. So rather than getting an average of the data every 5 minutes, you're seeing that data pretty much in real time. And there are various ways to stream it. Again, Max has mentioned this. There are various common open protocols that are used for that. With regards to the tools that are used to do the streaming, I think gRPC is probably the way we would like to go forward, because that's a more open method than using proprietary tools that the vendors might have. And again, this can generate a lot of data. There are implications for the collection infrastructure. Max showed a picture of a dog being drowned, which was most distressing, but I think it was a very good image to illustrate the problem that we do have. We do have to have the tools that can collect this data. So for the high-speed monitoring example, I'll just quickly show Raoul was running tests between Surf and RNP a month or two ago over the new 100 gig Bella link. That was reported at the last workshop we had in March. There's links to it there. Thanks again to Surf and RNP for helping with that. The tests were run for very short durations, like 30 seconds or 60 seconds, to minimize disruption to the link. The link's a 100 gig link, and if we were pretty much filling it on top of the production traffic that was there, we didn't want to do that for too long. And we were achieving over 90 gigabits a second with those tests, which was great, using iPerf memory to memory. And then we could see, using both Brian and Surf, what the visualizations of those traffic patterns were when they happened. So the interesting thing here is if you compare Brian on the left, obviously, with Max's experimental system on the right, you can see with the Brian view, it's polling every 5 minutes and showing points and plotting a line between those points. You can see it's sort of got the same overall average, maybe between 7:40 p.m. and 8:05 p.m. But on the right there, you can see the specific runs that Raoul is doing, which are just running for a few seconds and then stopping. You can even see, I think it's per second, the data that's being gathered there. You can see how the TCP algorithms are going up and down as well with their throughput over the course, versus what you see on the left of just a couple of hills on the chart. You'll also notice, of course, because SNMP is sampling, you don't see the highest peaks. You see an average of a peak of 35 gig, where we know from looking on the right, you're going to around 90 gig there. So you get that much finer detail with streaming telemetry than you do. There's horses for courses, as the saying goes, but it's important to understand the differences. I think maybe as well something for Keith or whoever to consider, maybe Brian, rather than showing a continuous plot, should maybe show that as a bar chart rather than a continuous plot to emphasize what's happening there, maybe. Just a thought. Here's another streaming telemetry example that Raoul included in his talk last month. Again, this just shows you the finer level of detail you can get. So on the left there, you've got 3 runs of iPerf3, and on the right, 3 runs of iPerf2. And each of those runs is using a different TCP congestion control algorithm. So you can see the effect of those on the runs. You can see on the right there, the packets per second that are associated with the throughput that's being achieved, etc. So it's again a much finer level of detail that you're seeing. So you're seeing the throughput, packets per second, and interestingly as well, you're collecting essentially in real time the egress buffer occupancy and the egress buffer drops, as well as errors. And I think the buffer occupancy is something we've been interested in. We're looking for edge devices for network performance testing. What size of buffers do you actually need in order for these high throughput flows to happen effectively? We're using or going to use an edge core wedge with RARE in our 100 gig network performance test facility. That only has a 16 meg buffer. I mean, a lot of the devices you buy from Juniper and Cisco, likewise. Is that going to be enough? The sort of data we've seen from this suggests that at least for a test facility where there's no complex transfers happening behind it, that should be enough. But if you've got this sort of real-time data, you can actually see what the effect is on the device for that. There is an implication here for Frederick and Zaba and the RARE team that we are going to potentially be asking for streaming telemetry for RARE soon. I will have that conversation shortly. But I think it's this sort of detail is the important thing that you can get in near real time that's valuable. So a few thoughts here. Obviously, streaming telemetry can produce a lot of data. Therefore, we would need to think about how practical it is to keep that data for a long time if you wish to do that. We think it's going to be very useful for our network performance test facility. We're currently, on the next slide, I'll say a little bit more, currently setting this up on our 10 gig test facility, but we are deploying a 100 gig test facility soon, and we'd like to have it there as well. So you can see the fine detail of the traffic patterns, as I've shown a few slides ago, that can be quite helpful with the diagnosis to complement what you might get from the perfSONAR tests that are running over that interface, flow information, etc., etc. And we think it might be, from the GÉANT point of view, that our backbone, it might not be something we turn on everywhere all the time, but if there are problems being observed, it might be something where you can, through the automation of those devices, turn on streaming telemetry for a period of time to gather more fine detailed data if a problem is there. So that might help you with the diagnosis of the problem, where it's reported, of course, which is, as Max has suggested, it's the support for streaming telemetry isn't 100% everywhere yet. Now, this doesn't give you the full view like in-band network telemetry can, which Mauro will be talking about soon, into the detail of TCP, individual packets, etc. But it is a very nice, as I said, a surgical tool that you can deploy and use. And then just finally here, we are setting this up within JISC. We're setting up a test bed for this. We're always working with David Richardson from our engineering team. We've got a Juniper EX4600 that's hosting our 10 gig network performance test facility that provides iPerf, perfSONAR, Globus endpoints, etc., that our universities and members can test against. The collector is running on a VM behind the EX4600, and that's we're setting it up using gRPC rather than the Juniper proprietary approach. And some words you'll have heard already this morning: Telegraph, InfluxDB, and Grafana as the tools for that. We have run into some bugs with that, or Raoul has. we're literally working on this as we speak. One of those is in the Telegraph issue tracker. The other issue is that the plugin that Raoul is using, the OpenConfig plugin, seems to only work without SSL. And unfortunately, and it's good practice that on GÉANT backbone, we insist, or we want to encrypt everywhere. So we really want that SSL working to deploy this in production. So we're working to address those. And we hope to be running soon, but hopefully we can work with the other NRENs here that are interested in this to progress this quickly. So that's all I wanted to say. Clearly, Brian is very useful, and streaming telemetry is very useful. Question is, where do we see the value out of streaming telemetry? What do we want to do with this as NRENs and organizations? Can we share experiences, configurations, etc., and best practice? And the question for the GÉANT project is, are there things you'd like to see the GÉANT project working on in this area, either the current GÉANT project or for Ivana and Pavle for GN5.1 that starts next year? So that's all I wanted to say. Thank you. Back to Mauro for some questions, hopefully.
Thank you, team, also for keeping very well the time. I think that the floor is open, so if anyone has some questions related to this quite interesting view of streaming telemetry evolution, please.
Hi, this is Rick Havern from GÉANT. I had a question for Max from SURF regarding your implementation of streaming telemetry. Do you use anything like Splunk to capture your logs?
Yeah, we currently use Splunk for collection of our logs, yes. Okay. Yeah.
So when we tried to implement streaming telemetry, we ran into an issue where the streaming telemetry caused an explosion of log messages. Yeah. Did you experience this as well, and have you found a way around it?
Yeah, we haven't used streaming telemetry for the collection of log. We still use traditional syslog. I don't know if that's what you mean. But...
Yes, the issue that we ran into was that enabling streaming telemetry caused root logins, which were not suppressible in syslog. And as a result, we ended up exceeding our licenses on Splunk. Yeah, so we had to turn streaming telemetry off until Juniper could fix the issue.
Okay, yeah. As I said, I did some very preliminary testing with the GRCP, and I just this morning a colleague of mine said that the logs at Splunk exploded due to the root logins here.
Okay, so right. Clearly, it's still an issue. Okay, fair enough.
Yeah.
Thanks.
Thank you. The next question comes from Otto. Please, Otto, the floor is yours.
Yes, Otto from SIKT, or ESnet, as it was called for many years. I mean, you are definitely collecting a lot of valuable data and just growing in number per second with the telemetry. And it seems that the way you utilize the data is currently more or less to feed it into not the database, of course, but also into Grafana and then present it visually in different, graphs or different shapes and forms. Do any of you attempt to do anything more? Try to analyze the data and search for patterns, generate some collection of events, something in that direction?
Not yet, really.
All right, because I'm just thinking it's a good path to follow to sort of compress the data sets and pick out interesting events which you can then store over time.
Yeah. Yeah, the potential for streaming telemetry in a high resolution has its benefits, and you see some articles about microburst detection and stuff like that. So that would be possible.
Okay, so
but I haven't done any of that specific analysis. But what was interesting from Tim's Tim, yeah, sorry, is that you could see the effect of window sizes in the streams. So that's very interesting. I thought that was interesting.
Thank you. The next question is from Andy, please.
Hi. So one thing that strikes me as we were talking both about the streaming telemetry and the SNMP was, you know, I think our conversations about this tend to be very, I'll call it IF-MIB focused, right? It's traffic errors, discards per interface. One of the challenges at ESnet, you know, we've had about being able to move to streaming telemetry was just parity with the data that we can get out of SNMP just doesn't seem to be there, right? So the IF-MIB focus is you know, you can get a little bit of parity there, but when you want to branch out, like let's say look at Q stats or power consumption or prefix stats or other things that you can get out of SNMP, you know, it's really just not there. Has there been any look at like what you can get beyond just your standard interface traffic errors and discards, or is that really kind of all you're playing with at this point?
Well, actually, my experience has been a bit different because you get a lot of data out of the streaming telemetry in the sense that I could see the buffer experience of occupancy per queue in the and stuff like that, what you were mentioning. So there's a lot of data there.
I don't think there's any doubt that any of us don't want streaming telemetry. I think we're all aware of the shortfalls of SNMP and the richness of data that streaming telemetry would provide. It's just getting the damn thing working.
Yeah, that's the main.
Well, I guess the other question is if there are elements missing that streaming telemetry doesn't provide. Is there a hybrid approach where you poll for the more less traffic-oriented information and buffer-oriented information, but use streaming telemetry for the thing that you're more interested in having in a more live feed?
Yeah, and I guess I should preface that too. It's also very vendor dependent. I think the Junipers are pretty good with their coverage right now.
Yeah.
We have to deal a lot with the Nokias and things like that, and just even in SNMP, their data model is very, very different. And so like you mentioned like the description problem, like you know, associating that with things. With like the Nokias, we have that times 10 with the data model and associating snaps with, you know, virtual interface names and things like that, which I mean, I think just kind of points out the importance of what you guys are looking at next, which is sometimes you just can't avoid that aggregation step when you want to be able to search on things certain ways. So
yeah, it's not there yet. Yeah.
Thank you. The next question is from Frederick.
Hello. Yes, it's more a comment with respect to what Max presented. I second his observation related to SNMP. Just for information, we played at first with the P4 switch and the RAR network operating system to enable SNMP MIB, and basically it's just the IF MIB first, and we use the LibreNMS, and from that point we managed to have a clear monitoring at 5 regular 5 minutes interval, and by curiosity we just decided to switch to LibreNMS aggressive polling mode, which is under 1 minute, which was great. We had the interface for the P4 switch for almost 5 hours. But I don't know why after 5 hours, the control plane, the Linux itself went down, and it was in a broken state. We just had to reboot it, and that was crazy. So that being said, we had these issues, and then we switched to another polling model based on Prometheus. So basically, we had deployed the Prometheus agent at free router level, at the control plane level, and I'm not sure if I can show my screen real quick. Yes. So, and basically, if you see my screen, this is the whole list of metrics we are importing. Just to answer the question, the comment from, sorry, I forgot your name, from the person from, I think it's ESnet, where we are basically exporting everything that is visible from the control plane point of view to the northbound NMS, not based on GÉANT and telemetry, but based on Prometheus. So we are exporting all this dashboard, ranging from LDP, BGP, BMP, all this stuff. And just to give you an example, it takes 300 milliseconds to collect all of these metrics on this equipment. So if you look at it, we have a bunch of collected variables that are predefined, that are defined at the control planes dynamically without using any predefined GÉANT model. And it's quite a good compromise with respect to telemetry. We can export the same thing with telemetry, and the impact, if you see the impact on the element, is that at the control plane level, it survived. It's running since 2019 without obviously some reboots and stuff. But we usually don't have any huge workload besides, and some of these equipment are having the full routing IPv4 and IPv6 level. So I guess that I don't know why SNMP is really not optimized to have a huge process, answer request process. But I really think that we can switch to either having a Prometheus agent if you have a programmable operating system, or in that case, switch telemetry is good. But telemetry means that you will have two different problematic. One problematic is the producer consumer problem, for example, related to the IFMIB. Here, clearly, if you work at 100 gig and you scrape every 30 second interval the data, you will have a producer consumer problem for your NMS. By the way, at the P4 switch level, we are scraping every 30 seconds. But the thing is that what would be great is it seems that we are doing the same thing at the same time. And from our case, we plan to activate telemetry and activate network telemetry at the platform level, at the GÉANT lab level. But it would be great, for example, to have a starting point like what you are doing, either what you are doing, Max or Keith, with respect to Brian. And we would love to. I tried to find the source code for Brian, but I could not access it. But if for any it is possible to access it and put it into the GÉANT lab, we can try to work on something maybe together if you are interested. If not, I still really think we should reuse the great work you are doing, and we are looking forward to activate telemetry at the P4 lab level.
Yeah, thanks, Frederic. I'll have a word with Eric about that.
Andy, you have still your hand is up. Do you want to add any comment?
Oh, sorry, I just forgot to raise it. There goes Tim's comment about me thinking clearly at 6 a.m. in the morning. So,
thanks a lot. If there are no other hands raised, it's almost 12:05. I suggest we stop here for lunch break, and we will convene back at 1. Sorry, let me check the program, because if I remember correctly. Yeah, and we will convene back in 1 hour for other type of telemetry approaches. Thanks a lot for joining, and see you in 1 hour.
Okay.
Tomorrow.
Bye-bye.
Okay, it is 1 p.m. sharp, so we'll restart our second telemetry on the data workshop for the second session. The second session will present different telemetry approaches. We will have a telemetry that is aiming to detect fine reliability trouble that will be given by Otto. There is also Tomáš who will present us the synchronization of a programmable device. But we will start with Mauro Campanella, who will present his work of a team, the data plane programming team that is leading in the network technology and service development work package in GN4-3. And he will present the results of this team regarding in-band network telemetry. Mauro, the floor is yours.
Thank you, Xavier. We will start, we will show the results and the lessons learned and the ongoing effort of this group of people that is looking at in-band network telemetry. Just a short recap of what is in-band network telemetry. The idea is that given that we have now new software and new hardware, it's possible to modify packets in transit and avoid to follow the strict rules of SNMP or even streaming telemetry information, because you can insert your own information and recover your own information from the routers using something which is very similar or based on data plane programming. It is very simple. It has a source node. The source node gets a packet, inserts information in form of a hint header. Then the packet follows the normal path to the destination. In transit, another node can add further information. And at the last hop, usually there is a sink that collects the information and send this information outside the network. The packet then follows the traditional route to the end. Why INT is a data plane programming application? Because it alters the structure of every packet. That's the main difference in respect to streaming telemetry, which acts on the routers, but does not changes anything in the packets themselves or in the traffic. Altering the structure means that you can add information, or you can even modify the information on the fly. That is useful if you want to do something which is not strictly related to switching, but it's something else. Having the possibility to look at the packet with fine granularity, then you can really personalize what you want to look at, and monitoring can be directed to specific single flow instead of an aggregate. And the mechanism is fast enough in real time, because in the data plane, that you can forward information in the control plane. This is used, for example, in various places already to control the congestions in data centers, redirect and avoid congestion in case of very large flows. We started in, well, the idea started in 2019. We started working 1 year later, more or less. We focused on P4 as a language devoted to this kind of data plane programming, which is very well suited also for INT. And the advantage was that new silicon appeared at the same times, which was on one hand enabled for this language, and on the other hand was very capable of modifying the packet in the fly, even at the highest possible speed, 100 gig and above. This is what we did and what we are doing in a testbed. The idea is that do not modify the production environment, act as an end user, and as an end user start exchanging packets, packet with INT between the various sites, collect them and see what happens. In listening to the presentation this morning, I realized that if you want, there is a top-down approach in monitoring, which is now SNMP streaming telemetry, in which you get from the large switches, large environment, with limited amount of data, and you go down because you are more interested in more and more interested in fine-grained monitoring. And INT you can consider is a bottom-up approach in which you really start from the network, from the single packet, and you can start looking and adding information on the packet flows themselves. What we did was very simple. As INT information, we decided to have timestamps, sequence numbers, and a sequence numbers of packets. So essentially only timestamps and sequence numbers. And through that two characteristics of each packet, you can understand very well what happened to the packet along the path. We tested various dimensions of flows from 1K to 300 packets per second. It looks a large amount of packets. In reality, we will see is few megabits or even 5 megabits, but even if it looks or reads as a low capacity, in reality, it generates a lot of information. We also decided not to focus on a single switch platform, but to have more platforms that I will detail later. This is an example of, in practice, what happens when we test a flow through the GÉANT network. So it's production environment. We act as end users. And end users in Italy, for example, can send int-tagged packets because there is on the local environment a tagging on a UDP flow. The packet flows through the GÉANT network and then goes to, in this case, an FPGA in ESnet, which collects the packet, takes out the int information and sends the int information to PSNC in this case, where we decided to have a backend, essentially. Backend is the collector that collects all these int information extracted from the packets and stores them in the usual suspects, InfluxDB and Grafana for visualization. These are the platforms we decided to look at because we wanted to understand two things. If that int approach was usable and in which range of equipment, starting from what is a virtual environment, BMV2, to DPDK, which is a more realistic hardware-based environment, but on off-the-shelf PCs, to the high-end silicon FPGA and Tofino. This is an example, the only example that I will show you probably. Everything works well, even surprisingly well, apparently, because this is a simple flow, a simple UDP flow, 5 minutes of it, which means a lot of packets, 500,000 packets in just 5 minutes. And through the simple timestamping and sequence number, then you can understand what happens to the packet rate. And the packet rate is at the microsecond level, you actually tens of microseconds level, essentially. And you can see that the packet rate fluctuates around the average value of 2000 packets per second. The flow is 1 megabit only, but nonetheless, the amount of information you can extract that is very interesting. The good thing is that no reordering, no packet losses. We were very happy. The NRN's network works very well, even on long distances. And when you see that also the interpacket arrival time is fairly constant for a 2 megabit range, but there are strange behaviors. Let's call them strange, something that you will not notice having a larger granularity. In this case, I just connected by an arrow what is a drop in the packet rate. It goes from 2000 to 1000. And at the same time, you can see on the associate plot of the interpacket arrival time an increase in the delay of arrival of packet time. I understand that as buffering, temporally buffering of the order of a few microseconds, of 1 microsecond, 2 microseconds. The scale of the picture at the bottom is 100 microseconds of main divisions between the points. what we learned through these testing, that actually the virtual environment is good enough. Of course, you can say that being a virtual environment will not scale to 100 gigabit per second for every packet, but this is not the goal. The goal is to understand if that can provide a nice tool with minimal effort. And in that case, even with only a virtual environment, you can easily generate a fairly stable few megabits per second traffic, which is what I just showed you. So even in that case, it can really provide a good tool. Tofino switches, that's the opposite, if you want, on performance, is a feature rich. It was engineered for P4 in mind, so it's very well suited to accept that kind of programming. There are some issues with timestamping on the way that Tofino does it, but nonetheless, it's very rich in the capabilities to alter the packets and to understand the packet in data plane programming. There are some licensing issues as usual about the program, because this is not just a completely sealed box. It's something that you would put your hands on and add your own software, and that creates some licensing issues with what now is Intel. FPGA, fast, flexible, very convenient, very powerful. The point that we started to realize at that point is that the P4 compiler, the compiler from the high-level language to the data plane itself, is vital. That compiler translates to the P4 to the local language of the FPGA card. So that's even a dual hop. Hardware insight, if you want to start managing Tofino or FPGA, hardware insight is essential. You need to understand how this hardware works in detail if you want to start programming that hardware in detail. So that's the other side of the scale of using this data plane programming. DPDK, intermediate between virtual and physical, DPDK is something that is optimizing the performance of a traditional off-the-shelf hardware, PC or pizza box type of equipment. It has quite good performance up to probably a few gigabits if you optimize it. The current testing that Tomáš, that will speak later on timestamping, will see is about, we are now reaching 1/2 or 1 gigabit per second of full packet management. You need to be very careful in combining the packets, since you are responsible of the system, because you may buy the CPU from one side, the interface from another side. You have, and you want to go to fine-grained detail, then you have to carefully choose the network interface cards, especially for timestamping. Again, Tomáš will tell you more about that. And DPDK compiler may vary also in this case. This is just to show you that the more you go into the detail, the more you discover of behaviors that can be due to the hardware, to the software, to buffering at various ranges and so on. So this is a completely open field for understanding the behavior of the network. What are we doing now? We are bug fixing the final bugs. We open the various platforms. We are testing a new collector because exactly for the same reason that was told this morning, this kind of approach, bottom up to monitoring, creates a very large amount of data in principle, even for small flow. That means that you can have a collector or something that collects the information that applies some filters to them. For example, if the data for this packet is identical or almost identical to the previous one, then I will not store that in the database. I will just mark that as equal and continue. And that will drastically reduce the amount of data you have to store. We are doing systematic measurement and calculation of the environment in a LAN, and then the next step is to do systematic measurement of a production environment like day one I've shown before. If I have to summarize our experience with data plane programming applied to int at least, well, it's not business as usual because two main things are required: expertise and human beings. And the combination of the two is very difficult because we are now in a fast-changing environment. So before embarking in a complex environment, as it was well said this morning, ICT is as important as network, and we have to find the expertise also in not just in software programming, but also in understanding the system and understanding the network. That's very important, and in my opinion, this is the future. In GAR, we recognize now that we can't have people working on a specific, well-selected area. Very often is needed a person that understands the environment and has at least a good understanding of various areas in ICT. INT offers a very agile tool. So I just showed you INT that works for timestamping and sequence numbers, but of course you can add to INT a lot of other quantities that pertain to queue sizes, local or real-time queue sizes, some elaboration that you can do on the packets on the fly, something that is useful for DDoS or security and that. What is important is that since you work at the data plane, then the hardware supports you to do that in real time at least. There are a lot of transient behavior at the microsecond or even at the millisecond range. Whether or not they are important, that is up to us to decide. I have evidence that some of these transient behaviors are important, for example, for real-time applications like video. Very efficient or high-stream video can be impacted if it is in real time, if it is an interactive video, then can be impacted by these bursts. The nice thing is that we do not need to operate on the production environment. Some of these measurements can be easily done by the end users using some relatively cheap equipment and still understanding very well what is happening in the network itself. If you are a service provider or an NRN, then you can go to a much higher level of information, for example, about the BGP flapping or other things that happens in the networks. Timestamping, that's key, in our opinion, to really focus and synchronize things at the different levels. Closing, last slide. The point is that we can go to understanding the microsecond level or millisecond level with simple ICT hardware, pizza boxes, a virtual environment or a DPDK-based environment which can help you reaching higher capacities. If you want to go to do more, because you want to look at more than one flow, or you want to specify and look at all the packets in a 100 gig link, then probably you will need specific ASICs, of course. I think we need to create knowledge. I think this is also one of the reasons why we're having these workshops. We realize that we want to understand more, and then we need to create more data, and then we need to understand how to treat the large amount of data. What is happening is that if we produce enough data, and TimeMap, for example, has some experience shown at the last monitoring workshop, then you can start applying machine learning to that large amount of data and discover interesting features. Having that, I will stop here. The next slides will provide some references where all our work can be found, including the P4 int code, which is on GitHub for the virtual environment for the Tofino chip and I hope you will be interested. Back to you, Xavier.
Thank you very much, Mauro. Thank you also for keeping the times. Thank you very much. Is there any one question, burning question, or if not, we can have the question at the end of the three. Okay, so we thank you very much once again, Mauro. We will go now to the next presentation, which will given by Tomáš Martínek from SIKT, who will explain us how to synchronize this programmable device. Tomáš, the floor is yours.
Okay, so hello everybody. Can you see my slides?
Yeah, yes, yes, we can.
Okay. So as Xavier said in this presentation, I'd like to talk about time synchronization in P4 programmable devices. Just to know that this work was done in the same group in the scope of GÉANT GN4 project, as Mauro said before. So I'd like to more focus on the topic of time synchronization. As Mauro said, the timestamps and clock synchronization is a very important feature of in-band network telemetry. It means that at the level of each INT node, there is need to take information where the packet arrives to the measurement node, and also it's important to record the information when the packet leaves the node. So using these two timestamps, incoming timestamp and timestamps where the packet leaves, you can easily calculate, for instance, hop latency. And if you also have an information about queue occupancy at the level of each INT node, you can easily detect the bottlenecks in your networks and do some appropriate steps. So in this case, the timestamps and clock synchronization is a very important feature. It also depends on your specific use cases. If, for instance, you are focusing just on measuring the inter-packet gaps, in terms of clock synchronization, it's important that INT nodes preserve their local clocks stable. On the other hand, if you have more complex use case, and if you need to measure, for instance, one-way delay measurements along all your infrastructure, you also need a global clock synchronization. So it means that all nodes try to share the same global clock and try to be as close as possible to global precise clock for these nodes. Okay, so the goal of this activity was to analyze and test capabilities of the current P4 programmable platforms in terms of recording the timestamps and also in terms of clock synchronization. So in our group, we tested three types of the P4 programmable platforms. We started with software-based platforms, especially with BMV2, which represents the basic reference model and simulator of P4 programs. Then we also tested the DPDK-based implementation, such as P4 P4S and P4C2 DPDK. And also we tested P4 backends based on Berkeley packet filters, such as P4C eBPF, XDP, or UBPF. More interesting was hardware-based platforms, especially SmartNIC-based, for instance, NetFPGA, Netco P4, or Netronom SmartNIC. And also we tested these features on switches based on Intel Tofino chips. So in following slides, I'd like to summarize some major findings about the timestamps and clock synchronization. So the first surprise for us was that some platforms don't support timestamp at all. It's especially true for software-based platforms like T4, P4S, P4C2D, PDK, and others. So it's not easy to use these platforms for INT implementation. On the other hand, all these platforms are typically available in the form of open source. So if you have a capacity, you can add this functionality to these compilers. So that's the first thing. If you find a platform that supports the timestamps, the second important finding was that these platforms differs in timestamp format, range, and meaning. So in following table, you can see examples of different platforms and the timestamps they're using. So for instance, some of the platforms use 38 bits for timestamps. Some of platforms use 64 bits. The values stored in this number of bits represents different things. So sometimes the number represents the number of microseconds. Sometimes it's number of nanoseconds, and sometimes the number represents the number of units derived from the clock signal source. So number of ticks of the clock signals. And typically these clocks are referenced from the input Ethernet interface. So it's measured in 8 nanoseconds or 6.4 nanoseconds units. So as you can see also in the meanings, the timestamp differs. And some platforms allows you to adjust the initial value of these timestamps. So you can easily, let's say, set these timestamps to the value that represents, for instance, the Unix epoch. Other platforms don't allow you to adjust these timestamps. So these values simply represents, let's say, number of microseconds from the switch start or other things. So as you can see, the timestamp supported and format differs significantly. And this is important, especially if you want to, let's say, build your infrastructure from different type of platforms. If you want to, let's say, combine Tofino-based switches with FPGA cards or software nodes, you have to take care of these things, and you have to know about these issues. Okay, so second important thing is the impact of P4 architecture that used by a particular platform. So you have to know that each platform may use a different P4 model or P4 architecture. So since the newer version of the language P4.16, which supports different models, you have to take care about the model that a specific platform use. For most hardware switches, it's typical that PSA architecture is used. So it means this is a basic architecture composed of ingress pipeline, traffic manager, and egress pipeline. In case of SmartNICs, they usually use a simplified version of this architecture that use just an egress pipeline and traffic manager. Yeah, so the simplified version is typical for SmartNICs. Also, it's very important to understand the moments and places where the timestamps are recorded inside this architecture, because some architecture allows you to take timestamps when the packet traverses between physical and MAC layer. Some platforms allows you to record the timestamps at the beginning of ingress and egress pipeline. And some platforms allows you to take the timestamps anytime you want, just simply by calling a specific external function inside your P4 code. So you need to know about these differences and change the P4 program according to specific platform and specific characteristics of the place or the places that the timestamps are recorded. So it's very important to not be surprised that some architecture have only ingress pipeline. So in these cases, it's very hard to take, let's say, timestamps when the packet leaves the switches, and also it might complicate the calculation of hop latency. So especially if you want to implement the INT know that there might be problem and you have to know about this. Okay, finally, I'd like to talk about clock synchronization. So clock synchronization is important to preserve your local clock stable enough. Not surprisingly, some P4 programmable platform don't support any clock synchronization. So in that case, the accuracy of the timestamps assigned to the packets gradually drift, and the size of this drift is typically dependent on the quality of the clock oscillators, of the crystal oscillators used in the particular platform. And also it's very important to understand that this accuracy may drift, for instance, in terms of microseconds every measurement second. So it also depends on your use case if this accuracy is fine for you. Some of the platform use synchronization using network time protocol, NTP, which is the basic approach how to synchronize clocks inside the networks. It's original software-based approach, and the accuracy of this approach is in orders of milliseconds. So also this depends on your use case if this accuracy is fine for you. More advanced platforms also supports PTP synchronization. It's a next generation protocol called precise time protocol. This protocol allows you to achieve sub-microsecond accuracy, but on the other hand, the hardware support is required for this kind of protocol. And this is especially supported by specific network interface cards, and also it's supported by Tofino chips. Here it's important to note that if you need to achieve high accuracy of the PTP protocol, it's not only important to have endpoint devices supporting the PTP, but also it's very important to have devices or switches along the path between the source of the precise time, it's called master, and the endpoints. And all these devices along the path should support the PTP. So in principle, it means that if the PTP packet is traversing through the network, so switches along this path should calculate the so-called residence time. So it means the time the packet spent inside the switches. And this residence time is then put into the correction field inside the PTP packets. And this field is then used for calculation of the time offsets, and is very important to achieve a high accuracy of the PTP synchronization. Surprisingly, if we look at the operations that are needed by PTP switches, it can be easily implemented using P4 programmable switches, because it's just about calculating the residence time and updating some specific field in the packets. So it means that if the P4 programmable switches became widely used in our networks, it also will support a PTP protocol in our networks, because it's the implementation of the PTP inside the P4 switches is almost for free. So it's very nice feature of P4 programmable switches. Okay, finally, I'd like to summarize my presentation. So as you could see, existing platforms vary considerably in terms of supporting of timestamps and clock synchronization. In case of the software-based platforms, timestamps and clock synchronization is not usually implemented, or they simply use a system time which might be synchronized also using NTP or PTP. Also, it's important to know that the measurement accuracy is affected by the software layer overhead. So as you know, if you are using the software-based platform, the packet is going through the network interface card driver, then through the kernel, then to the application, and we can see a lot of overhead along this path, including interrupts, context switching, and so on. So all this overhead affects the accuracy of the timestamps for the software-based platforms. On the other hand, DPDK-based platforms are the most promising from this perspective because they bypass the kernel. They don't use interrupts and use polling mode. So the overhead, all this overhead is reduced. But still, when we did some measurements, the accuracy of the timestamps assignment in these DPDK-based platforms is around 1 microsecond for most incoming packets, for let's say 90%. However, for some packets, we can see some outliers that are achieving units of milliseconds. So in most cases, the accuracy is sub-microsecond, but time to time, it flows up to 1 millisecond. In case of hardware-based platforms, the situation is it's better. The timestamps and clock synchronization is implemented on almost all platforms we've tested, SmartNICs and hardware switches. In these terms, the Tofino represents the best production quality platform in terms of supporting the timestamp and clock synchronization. And all this information I mentioned and also others are available in the white paper we are preparing and which will be coming soon. So that's all from my side.
Thank you very much, Tomáš. Thank you also for keeping the time. There was just a questions that you can maybe answer and during that Otto is starting to sharing his screen. There was a question from Marco Schwarz. Oops. What specific Tofino devices with PTP support are being used?
Yeah, we were using wedge switches and also STORDIS switches. So for both cases, the support was available.
Thank you. So there will be certainly other question at the end of the session. Now we will have a presentation that will explain us how you can detect some reliability issues thanks to a fine-grained level of measurements, hand-to-hand measurements. So Otto, the floor is yours.
Thank you. Thank you very much. Yes, I'll give you a quick intro to what's going on of what we call analysis in our end-to-end measurement platform known as Microdep. We presented this platform a few times earlier, so I'll focus on the analytic parts in this presentation and just give you a quick intro to the platform. Microdep is really a platform doing something similar to what the two earlier presentations are doing. It's generating or trying to look at traffic flowing through the whole network from one node to another and study what's going on with this traffic. It was initially a measurement project more than 10 years back, but it's now also a measurement system and a continuing project. The main objectives of the project was to reveal dependability issues at a fine-grained level. So we're trying to go to as fine-grained level we can, not as fine-grained as you seem to manage with the P4-based system. And again, end-to-end measurements. And the overall goal is to support improving routing configurations in our network, but also globally, because our users, they use the global network. So this, if you want routing to be better, you need to look beyond your own borders. So the system quickly it's under the hood, it's fairly straightforward. We are generating packet flows, 100 packets per second. That's the resolution we are at. We're doing it 24 hours each day, and we also run trace routes next to this every minute. Currently, we have 51 nodes in our NREN in Norway and have some 200 flows between these. And globally, we have managed to get access to 24 sites, so VMs mostly, some physical machines around the globe, and run around 240 flows between these. And we have also 8 of our nodes are in data centers, because data centers are end nodes for much of the traffic from our customers. We do real-time and event analysis on these data sets. So when the data is coming in to our the receiving end, we start analyzing them immediately to try and extract something interesting from the flow. So we have both packet loss analysis, queue analysis, and also we do route failure and route change analysis now. And this is sort of the details I'll get back to in this in the coming slides. We also would like to do some joint event and anomaly analysis to generate alarms eventually, based on the individual events found in the real-time analysis. And as you're probably thinking now, that doesn't this seem like perfSONAR stuff? And indeed it is. The sort of underlying mechanisms are similar to what perfSONAR offers. So we are in the process of integrating the toolset with perfSONAR, the platform. The results of the analysis are presented currently in a map, a colorful map here, as an example of what you will see when you visit the Microdep.net.no webpage. It's an open webpage, so anyone can have a look at it. You can select different measurement networks. You can select different type of events, a set of events we have extracted from measurements, and also different parameters of these events. And you may have an indication in this map. It looks like some colorful spaghetti because it's showing essentially the connections. So the lines are not at all the paths followed in any geographical sense. It's just sort of indicating from where to where the connections are going, and the colors indicate, in this example, the millisecond queue we have estimated for those connections. You may also click on these links to see more detailed statistics aggregated. We have some other views also in this tool. We have a trace route viewer where we try to visualize a path from end to end based on the collection of trace routes for a day, typically. And we have, of course, the more classical aggregated trace route table. We have some classical graphical ways of displaying a collection of events. So here we have delay or delay difference in delay over a time period between two end-to-end between Stockholm and Madrid. We also have a heat map, which essentially presents the same as the other map, but perhaps it's more easier to pinpoint which nodes, which connections are in have a collection of interesting events. So Trondheim measurement node here is definitely one which we needs to take a look at. So these events we are extracting from the datasets. First of all, we are extracting gaps or packet loss events. So we study because we are sending a constant bitrate flow through the network, so we know that what the flow is supposed to look like at the end. If there are packets missing, something has gone wrong or something has happened in the network. It was interesting to hear that timestamps was still something of an issue. We have scratched our heads quite many hours to what to do with timestamps, because since this tool is running in user space, the accuracy of timestamp are very much limited to the accuracy of the NTP protocol, and also to the extent of real-time support in the kernel of the operating systems running in each end, Linux, essentially. So we ended up with actually avoiding to look at absolute timestamps. And absolute time, we just assume that the clocks in both ends are stable enough. They don't change too much over some 10-20 seconds. And we just look at 2,000 packets, we keep that in our analytic tool, and use that as sort of a reference. And we find the minimum delay in those 2,000 packets, and assume that minimum delay has is sort of something we can refer to and compare towards. All right, a gap is essentially in our tool 5 packets lost, meaning 50 milliseconds downtime, similar to the old telephony standard. And then a gap is considered over or no longer happening if 5 successful packets are observed. We analyze the head and tail of these gaps, look at the 50 packets ahead of the gap and also the 50 packets after the gap, and do some statistics on those and present those. We also count smaller gaps, so even single packet gaps, and just give some summary stats for each day there, assuming that the smaller gaps are not necessarily hampering the quality of experience for the users. There are quite a few gaps to be observed. I have some diagrams here just illustrating what is seen here. So during a time, I can't remember the time frame here, but we have quite a number of minutes downtime here due to gaps summarized in a situation. And well, the counters here actually indicate that it's not at all a rare event that packets gets lost in the current global network. So Dragon Lab is mentioned in the slide set here, which is essentially our nickname for the global instance of the measurement toolset. We also extract jitter events. And this is done by applying the jitter and queue events. We apply the jitter definition from the RTCP protocol, RFC something, but it turns out that the jitter is not perhaps that interesting. It's only minor variances in the jitter we can measure, sort of in order of a few milliseconds. The top diagram shows here in one case, while studying rather the change in delay is more interesting, which we then interpret as a queue buildup. So we take the delay for end-to-end delay, the delay measured at the receiving side less the sending side, and then we remove the minimum delay we have measured from this window I mentioned, so to normalize in the sense what we see here. And here we can actually quite clearly see when the delay increases and have different bursts. And here we see that in the same case shown here, where we see hardly no jitter during the day here, we can see a burst in, or a high peak in change of delay during the afternoon here. So this queue buildup analytics seem to pay off well. As mentioned, we also generate some route behavior events. So first of all, route failure events, and this is essentially parsing through a lot of traceroute logs and searching for all these stars. So when we have a traceroute which never ends with a lot of stars at the final hop, we consider that as a failed route. And we also log other ICMP indications or messages coming from the log, typically network unreachable symbols popping up in the logs. And of course, this measurements here does not necessarily measure a failure in the network. They can also measure restrictions in routers and management, the layer throughout the network. But for most cases, it's intentional that the traceroute should work. So when we discover these events, it's worth telling operators that we can observe this. We've also developed a route change feature, which tries to extract when or detect when a route is changed from one path to another. And we ended up, this is not necessarily very easy. There's a lot of load balancing and activity going in the global network. But we ended up studying the change in distributions of seen IP addresses for each hop. And by applying some mathematics, some cross entropy to this, and looking at the differences in cross entropy, we could see to what extent change in the set of IP addresses for one hop is normal or abnormal. And by working with distributions, the system seems to over time learn what is normal for one end-to-end connection. This is promising. So I was hoping to give you a quick demo, but perhaps I've run out of time, so I should avoid that.
Yes, you have just 1 minute for you.
1 minute. Oh yeah, but that's enough. That's enough. So let's see here if I can.
1 minute for the demonstration. Wow.
1 minute demonstration.
It's a challenge.
It's a challenge. Let's see. I have prepared a screen here. Let's see if I can share that one instead.
But I may interrupt you, because one thing that you can do is also make the demonstration during the break if you want. But if it is 1 minute.
No, it's just 1 minute. So this is here you have the map again. So I wanted to show this is actually the live view of today, what's going on in the world with our measurements. And here I've selected the route changes observed. And one way of using these data sets is to, for instance, like this, we could look at one link I've looked at earlier today. This one between São Paulo and Trondheim. Here we have, if you click on it, we get some more details. We have several hops which are indicated as anomalous today. There's some time slots down here. Don't look at the undefined information there. It's to be added. But we have actually detected quite a few route changes. And if you remember 8 o'clock-ish, there was one, I think 8:07, 8:06, there was accordingly a route change. We can pop over to look at the gaps and see if to what extent such route changes might have caused the gap. Now we see gap information for the same connection, and and there's a lot of smaller gaps going on in this connection, sub-second gaps, so perhaps not that much to consider. But if we wind down here, at some point, or at least earlier, what happened? See it here? There's so many of these, so we need to go down to 8 o'clock. Oh, it was here earlier today. What happened, Olav? All right.
It's a gap in the gap.
I was hoping to show you that at some point we observed a much larger gap, but for some reason there we are. Here we have the larger gap. So 8:03, there was a 205-second gap observed, and this is likely to have something to do with the route change, which was observed a few minutes later. All right, I'll leave it with that.
Okay, thank you very much. Thank you, Otto, for this presentation or for this very quick demo. Do we have any questions for all of our speakers?
Muted, perhaps?
No, can you? Oh, Mauro, you are muted. Ah, no. Okay.
No, I have a question for Otto because it's very interesting, but I wanted to understand if the drops or events that he sees are on the network or on the end sites.
A good question. We cannot really know for sure, so that's something we need to you know, combine these data sets to try to see where in the network. And I mean, since we have a multiple end-to-end flows, we can do some cross correlation between those. So typically, I mean, now I looked at one end-to-end connection there, and I saw a gap. Now I should really look at another end-to-end connection which is flowing in a similar, or at least have some common routers in their paths. And then if I can observe the same gap there, we might well, assume that. So I mean, I cannot know for sure, but we can assume that it has something to do with this route change, for instance. And I mean, I didn't show that, but we could pop over to this visualization tool to see what's happened to the route during the day, and there you can very quickly see which routers are the ones which are involved in the route change.
I have a quick
combinations of data might give you a pinpoint opportunity.
If there is no question, I have a question for Tomáš. So if I understand, you need at one point, for instance, for your programmable devices to use, for instance, PTP and so on, but you need also a source of for the synchronization. I would say, I don't know, atomic clock or something like this. Do you have already think about how you can, which source you can use?
Okay, so typically, this as a source of the precise time is used a specific node inside the network. In case of NTP, it's called server. In case of PTP, it's called master. And these nodes are equipped with a special device that is connected to GPS, and this device is synchronized with this GPS, and also it's used in case of PTP, it's used as a source of the PTP messages that are spread through the network. Yeah, so this is a typical solution of the source of the precise time in the networks.
Thank you. Any other question before the break? If not, then we will have 20 minutes of breaks. I would like to thanks once again our presenters, our speakers, and see you at 2:20. And thank you very much.
Good afternoon or good morning, depending on where you are. We will now start our third session. It's now 20 minutes past 2. So the first presentation is from Marcos and Mihail from RMP. 1.5 years ago, we had a first telemetry and big data workshop, how we called it. And back then we had the presentation about Micromon system that was announced by RMP, a system for data sharing. So we are happy to be able to hear now what happened in between and what are the news from RMP in that area. So I give floor to Marcos and Mihail, and please, you can start your presentation.
Thank you, Pablo. So last year, as was said, actually in August 2020, we started a new data share initiative at RMP. And it was actually found some gaps into our internal processes. So I'll be giving today a brief overview about how Micromon helped us to initialize an internal activity to try to bridge this gap and actually provide this data to the community. So actually Micromon, it was an end-to-end project backed by the research community. And it was meant to look at the whole data sharing process coming from network collections that were done by RNP and doing a pipeline to a process, archive, and then store it for preservation purposes and having a way to let it be consumed by researchers. But actually, can you pass the slide, please? Actually, we really were limited by the initial phase. So there are just a few data sources at RNP that were available and that we could make available on this 1 year time frame. Can you go on, please, Michelle? So actually, this Micromon initiative was really impacted and could only get resources like perfSONAR that were already available through a public API, and also some topology information that we had from a grand map instance running. But one of the initial concerns that were NMP lacked processes to share the operation data that was already collected actually was continue to be a problem, because this external team couldn't change or evolve the internal processes by itself. So after this 1 year of the project, we halted the Micromon initiative and concluded that we need to work from the ground up with the operation teams to try to build this missing infrastructure, missing processes, to try to explore this later on. So this year, we actually try to do something different, actually more narrow focused initiative with collaboration from R&D, network engineering operation teams. And the basic idea is keep it simple and try to do what it can, so we can start it in-house and support it, so that later on we can include or integrate these external, more broader solutions. Otherwise, you always have this internal gap that will be the bottleneck for most of these initiatives. So in this case, we focus on sharing already existing data. So we have normally a short time, 3 months, or maybe more in some cases, data sets that are used for operations that can be delivered to the community, but there is a gap of how can we authorize, how can we select the data, do a lot of processing between the data owners and the request. So a lot of people that need to be involved, and we don't have that in place right now. So in this case, we are trying to extend existing tools. So we have some open Elasticsearch repositories. We have some cacti repositories, central repositories, a lot of repositories, but they're all siloed inside some team and doesn't have any way to share it in a secure and authenticated manner. So in this case, we are starting with these teams. So we generate internal knowledge and try to not replicate the data sets, but actually just provide a proxy, an API, authenticated API, so that it can be requested, authorized, and then someone else can replicate a data set with some subset data that it has been authorized to. So in this case, we are identifying internal needs for sharing data, in the sense that if internally in RMP, operation teams needs data from another domain, from a regional network, probably there will be more commotion and engagement to try to sustain this in the long term. So in this case, we're trying to look for network application services between these administrative domains. We have found some already, and also working with some early adopter researching teams that are using AI, so that we can try to either do some common simple use cases just to prove this approach, and also trying to give a more long-term research-oriented focus. And also, we are trying to create this framework to allow the separation between the policy enforcement and the data owners. So it's not feasible for us to have the network operators to try to find out if a data can be shared with someone. So actually, we need to define these policies of what are the personnel, what are the roles that can request for some kind of data, and have that as a policy that other groups, other more focused on authorizing groups can do that, and pre-allow or have a tool that could implement these policies, so that the network operators don't get frustrated or don't get preoccupied of whom the data will be shared to. So this way, you're trying to provide temporary permits to access subsets of the data that are available to federated users, and provide pre-validated anonymization workflows later on for sensitive data, and have this all preset and just create the workflows per demand. In this case, we're also trying to create a process where the information management department that doesn't operate the network, they can all be the active players on authorizing and giving access to everyone else. So trying to have a high level workflow on how this data can be shared and build in advance all this infrastructure so that it can be used by known network operators. So this is basically the context that I'm trying to introduce. And Michael will now talk a little bit more about the implementation that we are doing. We just started a few months ago.
Yeah, thank you, Marcus. Thank you for the introduction and context. Well, basically, we are trying to do here is building a system for sharing network data between different teams inside our organization and with the community, like Marcus mentioned before. To do that, we are using a very simple architecture, but powerful enough to grow over time with different data sources, policies, and use cases. On the left side of that picture, we have or already collected data network for our organization. And on the right side, we have researchers, monitoring dashboard, data processors, community data set, and so on. We are focused, we are applying or focus on that middleware so we can collect, transform, and deliver. That's a problem right now. Anything outside that square right now, we are not implementing at this moment. So some views of our architecture. Basically, it's a two-domain architecture. First domain, organizational domain. We have some components that can collect network data sources that are already running inside our organization. We will be able to apply policies to that data, transform that data, or enrich in any way that data. And finally, deliver that data for internal usage, or to provide that data, connect that data to the research domain, in which that domain will going to running a broker with the already sanitized private data. In that domain, we'll able to select what kind of data a research has interest in. Some details about our current implementation and tooling. We are basically using Spring Cloud Data Flow, that it's a framework from Spring project that allow us to create complex topology for streaming and batch data pipelines. The data pipelines are basically Spring Boot apps, Java apps, built using the Spring Cloud Stream or Spring Cloud Task microservices frameworks. The using node of Spring Cloud Data Flow basically simplifies a lot the development and deployment of applications that are focused on data processing use cases. First sprint of our current implementation. Basically, we finished that sprint a week ago. So this is the current status of our system. Basically, we developed a DataX portal. DataX is the nickname of our system right now. And we are developing a DataX portal. So the researcher, we have the ability to select a specific data. Once the researcher, let's mention that our current implementation is focused on MoneyPay use case. MoneyPay is the name of RNP perfSONAR service. Basically, because of perfSONAR data, it's mainly public. We select that use case for our first sprint of implementation. So the researcher can select what kind of test of perfSONAR test available on the system. It can select what kind of test, time frame, and so on. This portal will communicate to the Spring Cloud data flow, REST API, Spring Cloud data flow. So Spring Cloud data flow with that context will able to instantiate a task that it's responsible to collect perfSONAR data, and later on send that data to our stream inside a Spring Cloud data flow, and finally be able to deliver that data to REST API provided by the user. Here's some prints of our system. Basically, right now we have a local authentication system, but we are able in the next few weeks to integrate to federated access. Here, basically, we are building like a catalog of data sources inside our RNP. We are trying to populate that dashboard with all the data sources over time, but basically right now we have MoneyPig, that is data from perfSONAR. Here, the user can select what test type of perfSONAR. Test data will change according that test type. Obviously, we can select the source, destination, the time range of that test, and finally we can provide an API for the system be able to send that data. Here's some picture of our monitoring system associated with the Spring Cloud data. So we can monitoring our apps, collectors, data streams, and so on. Finally, our next steps for the next 6 months, we are thinking about adding access circuits performance metrics to the platform and network data for RNP backbone, which are exported router flows with sensitive information. From the portal side, I already mentioned it, that we are integrating with federated access, and we are implementing a feature that will be able to provide the ability to the user to schedule data request. So the user can select the frequency that the data will be delivered to other system or to another API. That's it. Thank you very much.
Thank you, Michel. I would just like to ask Antonis to mute the microphone. We hear the very heavy typing from that side. Okay, thank you. Thank you, Michel. We have time for a quick question if there is one from anyone from the audience, or if not, we can postpone. I mean, I have a couple of questions, but I will postpone this for the end of the session. Okay, if not, then we can move to the next presentation. This one comes from Andy Lake about perfSONAR data sharing. So Andy, please share your screen. And yeah.
All right. All right. Well, hi, everyone. I'm Andy Lake. So I'm from ESnet, and I'll be talking to you today about sharing data with perfSONAR. So I think most of us know what perfSONAR is, so I don't want to go into that too much, but just kind of wanted to kind of kick off by at least talking about the types of data that we store, because I think sometimes when people say perfSONAR, they sometimes mean different things. So, ultimately we're providing active measurements, right? And those can take a lot of different forms, which actually makes talking about the data sharing a little bit challenging. We have to kind of talk in generalities because we have like lots of users across many organizations, right? And we have all these plugins for doing types of tests. So someone could write a test that kind of throws some of what I say kind of out the window. So kind of a key challenge and a theme throughout as I talk is, we try to provide knobs that can adapt as kind of conditions change in that sense. But when most people think of perfSONAR, they kind of think of some kind of key, I kind of think of it as our bread and butter test, right? Which is like throughput, packet loss, one-way latency, trace route. You could maybe even throw ping in there. And so these are kind of all active measurements. You've got, one or two endpoints usually, or you usually have a couple endpoints, and you get some numbers out of it, right? So kind of breaking that down a little bit, right? So we have the test parameters themselves. Most of the time, again, this isn't required, but most of the time in our space, when we're thinking of those types of tests, at least, there's some IP addresses involved that you have to think about when you're thinking about sharing them. Then there's scheduling information about how often they run, and then test specific info. And then most of the time you get numeric throughput, packet loss, and things like that. It's also worth mentioning things like trace route. You get some contextual information, like the IPs of the hops in the middle. So there might be some extra considerations there in terms of topology getting exposed or whatever that you might have to think about. So, I think as some of the presentations have shown, a lot of times perfSONAR is a starting point for people when they're trying to get information public, because compared to a lot of the stuff we talk about in terms of network metrics, perfSONAR is kind of the boring one or the safe one you can think of, because of what it exposes versus some of the others. So I try to kind of highlight a couple, perfSONAR versus a couple of the common ones here. So, if you think about like interface counters, you were talking about there were some good talks on streaming telemetry and things like that earlier, and SNMP as well. I kind of think that is maybe like one notch above perfSONAR in terms of you have to be, additional privacy considerations. There usually you're looking at individual points in the network, which people may or may not be sensitive about, and depending on kind of your network traffic profile and things like that, it may or may not expose different information. So for example, if you're a backbone network, an interface in the core, it has a bunch of stuff aggregated on it. It's going to be a little more challenging to pick out individual behaviors and things like that, at least in theory. If you have an edge interface that basically connects to a single organization, depending on what that organization is, it might be a research institution, so happy to share that. Might be somebody in the intelligence community, less happy to share that, right? And likewise, if you're on a campus or something like that, obviously that changes and could be a specific dorm room or whatever. So there's some extra considerations there. And then flow is kind of, I think, one of them where there's lots of extra considerations, right? You have highly granular information about the endpoints in terms of IP ports. You can figure out applications and things like that. When you start thinking about sharing that data, you have to start really thinking about international privacy laws. And there's ways to kind of aggregate that information sometimes to get around those, either kind of hiding the IPs or not even putting the IPs, in whatever you're trying to show, breaking it down by organization or things like that. Projects like NetSage have dealt with that a lot, but definitely a lot of extra challenges there compared to the perfSONAR data. So kind of with all that in mind, the perfSONAR, kind of wearing my broad perfSONAR developer project, I think since the beginning, really one of perfSONAR's main goals was to kind of strongly encourage people to share the results as much as possible, right? Like the whole interdomain aspect of, interdomain troubleshooting, and all that is essentially at the core of what perfSONAR does, right? And so to do that the best way possible, we really want to be able to share data as much as we can. Now, possible is, and we can, is where things kind of get a little bit fuzzy, right? And so we acknowledge that, we have all these different users, bunch of different use cases. So we need different ways. We need some flexible controls around what people can do. And so, basically most of our controls happen pretty early on in the phase where you actually kick off the test, right? So we have this whole limit system we'll talk about in a second that basically controls who can initiate the tests. And so a lot of the concern too for that isn't necessarily even about the sharing of the results as much as it is about over testing, right? We don't want everybody running UDP cannons and eating up all the bandwidth on the network, right? So, you know, we ship with some common sense defaults. We have some ways to adjust those as needed, right? And then you also have firewalls and the other kind of usual mechanisms too at your disposal if you need them to implement a particular policy. So to kind of more visually, for those of you who are more visual, this is kind of our standard perfSONAR architecture diagram. Down at the bottom there is like the individual tools that are actually getting run, and then one layer up, the scheduling layer that's circled right there. It's kind of where most of our enforcement happens. So that's using a component called pscheduler that has the limit system that I mentioned, and we kind of try and cut things off there. When things get shipped up to the archive, so one nice thing about pscheduler is we have lots of different places we can ship it to. You know, the default one right now is something called ESmond. We're actually moving to something, we're moving to something else. Talk about in a moment as well. Basically, we don't provide a lot of access controls there. So kind of our general approach has been, if you're using our default stuff, at least, if you don't want it shared, don't store it. And if you don't want someone else sharing it, just don't let them run the test to begin with, is essentially the approach. And so I've mentioned the limits a couple times. It's a pretty broad topic. There's a YouTube video. I just sent my slides, and I think they maybe have already gotten posted. So very quick turnaround. Thank you on that. But there's a link here to a YouTube video that Mark Veit from Internet 2 put together a little while ago that talks in depth about the limit system. That's really good, and I encourage you to watch if you're interested. But at the end of the day, basically, pscheduler has this kind of built-in language for controlling what tests can be run. And we try to make a lot of like the basic stuff and maybe even some not so basic stuff pretty straightforward with relatively simple directives. And a lot of basically most of it's IP based as well in terms of who's requesting the test and determining what they can do. And so ESnet has long provided at that URL there some automatic generated prefix lists that kind of limit things to basically R&E traffic. I think some of the cloud providers, you can get prefixes for them. So you can easily kind of create these classes of requesters and then enforce policy accordingly. You can do some really complicated stuff using JQ, which is also really cool. And basically you can, any parameter in the test, you can make decisions on, you can actually even set defaults in some cases. pscheduler even supports priorities now for kind of bumping tests if a higher priority one comes in and things like that. So there's a lot of options there. If you get really deep in, I think it's important though to remember, don't overcomplicate your rules, because sometimes you can cause more problems than you want. And you know, at the end of the day, sometimes you have to lock things down or do things a certain way, but it benefits everyone in the community more if you know, the more places we can test. So don't overthink it. This is basically, you know, one thing to keep in mind too while going through those. So you know, we talked about kind of the scheduling layer. So I mentioned too, a lot of times you run a test and then you ship it off and store it someplace. So at that layer right now, in our default archiver, ESmond, as I mentioned, you really don't have much access controls. If it's published, you know, people can see it, right? Unless you, of course, firewall it off or do things like that. If you use one of the other plugins and ship it to a different type of database, obviously, you know, you have the ability to do whatever that database gives you the ability to do. And if you're an expert user, you can, you know, probably add some more fine-grained controls if that's what you want to do. So we're actually very close to a beta of perfSONAR 5.0. Marcos, who just talked, you know, wearing his perfSONAR hat, his team has been really helpful in helping get us across the finish line for that. But we're moving to OpenSearch, which is just Apache licensed version of Elasticsearch. Technically, that I guess will change because you have some built-in authorization options and things like that you could play with. By default, out of the box, perfSONAR is not really planning to leverage those. We really want to kind of keep the same open access policy, but for those who are brave enough to play with it, you know, I guess the option is there. It's probably worth mentioning. One other thing I kind of haven't highlighted either is, so we've obviously got the tests that we run and how we share that data, but another aspect of perfSONAR is what we call the lookup service. So there's a little agent that you can run on your perfSONAR hosts that register like the existence of your perfSONAR server. And then the idea is, you know, other people who want to do tests can find you more easily. UIs can use it to kind of create search type interfaces, to build things like the map that I have over there on the right. And so basically people have the ability to opt in or out by enabling this service. We turn it on by default on like our toolkit bundle, and I think our test point bundle. So our most popular bundles, we turn it on by default, but you have the ability to turn it off. I think you can actually even turn it off in the UI. You know, you can definitely turn it off just using system control and all that good stuff, right? But again, this is an all or nothing approach. We don't like have a way for you to store it and then write some fine grained policy about who can see the existence. If you're worried about that, just you shouldn't be publishing it at all in our public LS. The other thing worth mentioning too is the lookup service. Like everything is open source software. There are people that actually just run their own private LS for large internal private deployments where, you know, you've got a perfSONAR server living on a private network that no one can reach anyway. So it's kind of pointless to register its existence to other people. You know, we as perfSONAR developers maybe like to know that because it gives us a better idea of how many of them are out there. But, you know, for practical purposes, for most people, you know, it's not there. But maybe you have enough of them internally and you're using some of the UIs that it's nice to have it there so you can easily kind of search and build tests and things like that. Which kind of leads into another pattern we've seen actually quite frequently with perfSONAR, particularly in the commercial space and some governmental entities. I know like NASA, the space agency over here in the US, they have actually a pretty large internal deployment that they run. And really it's a private network. I think they're private addresses. And so really it doesn't make sense to have it advertising itself in the larger mesh or testing. And this is the case where I think just basic laws of routing, like you can't get to them. So nobody's testing to them, but it is a possibility and it makes sense in some certain cases. And so that's really it. So, you know, that's kind of an overview of some of the patterns and kind of perfSONAR's general approach to sharing data. You know, basically we have a lot of knobs for running and scheduling tests. It's kind of your, you know, up to the end user if you want to do more at different layers like archiving and things like that. And perfSONAR's been around a long time, and I think this has seemed to work for most people. And we largely benefit from the fact that, you know, at the end of the day, the perfSONAR data that most people are generating is not quite as sensitive as some of the other data. And of course, there's always exceptions, but that's it. So thank you.
Thank you, Andy. Okay, I suggest that we go for the next presentation and leave the discussion for the end of this session. So the next presentation is from Dan Doyle about the global research map. If Dan is around.
Yep, I'm here.
Okay, please share your screen and you can start with the presentation.
Absolutely. Let's see here. Folks see that?
Yes.
Perfect. Okay. Hello, everybody. My name is Dan Doyle. I work at a place called the GlobalNOC here in the United States. So good morning if you're over here, good afternoon or evening if you're over on the other side. I'm here to talk about global research map, but a little bit of a lead in as to what the backstory is here and kind of what I'm hoping to get across. So this is my brief agenda. I know I have 15 minutes. I probably have too much, so I might go a little bit quickly. Hopefully we can get it all in here. So real quick, I wanted to talk about what is GlobalNOC. And first, I promise this isn't a sales pitch. I have a point with all of this. A vendor did not sneak their way into this conference. Really, this is background for what Community Metrics and Global Research Map is. So if you're not familiar, we're a network operations center headquartered here in Indiana in the United States. We've been working with the R&D community primarily around this country, but also with some international peers like AMPATH, you know, for the last 20 or so years. If you want to know more, there's the website. And my chief role in all of this relates to data telemetry and visualization, hence all of the maps. So when we talk about telemetry, there's been a lot of great talks here, and as many of you are familiar, we collect troves of data about our customers, right? And it's in a variety of different ways. SNMP, I won't read all of these here, but there's a lot of different ways and a lot of different data sets that we can collect. And we also have human event data, such as maintenances. And we do this with a mixture of off-the-shelf components like Telegraph, with a lot of in-house components that we've written ourselves to handle things like automation and orchestration. And all of that becomes very important when we start talking about maps here. We end up using this data for a wide array of purposes. All of them are probably familiar to you in some sense or the other, right? We do a bunch of monitoring, billing, capacity planning, fault detection, and visualization, right? We're here to talk about maps. So when we talk about maps, I always use this thing that people are probably sick of hearing me talk about, which is that a picture is worth 1,000 words, right? Everybody's got a network diagram like here on the right. This is the iLight network here in the state of Indiana. It is our local RNA network. And you've probably got a map of your network that looks similar to this, or possibly more detailed if you're looking at the actual network engineering map. And these are great. Network engineers maintain these by hand. They're frequently out of date because it's just a PDF file that maybe lives on a Google Drive. And they don't really integrate with current traffic levels, monitoring status, maintenance information, et cetera. They're very static maps. So many years ago, we started making individual network maps for customers, merging this idea of a network diagram and incorporating a bunch of live data. You can see in the top, I believe this is the Abilene Internet 2 network, circa 2003, cutting edge visualization technology for the time. Over time, this has evolved, it's gotten prettier, it's gotten more interactive, and more importantly, it's gotten more automated. These networks change quite a bit, and if you don't have that automation, everything just falls apart really quickly. So this is all based on all of our mapping tech, including Global Research Map, which I promise we're getting to, is based off of a network topology database where everything sort of inside of it, as much as possible, has been automated. All of this mapping tech has been open sourced under the GlobalNOC repository. If you want to go check it out, you can go over there. There you go. There's my shill for our thing over there. So the way that the map building works here is that we've got maps that you can lay out with a human-friendly application, and they all tie back into the network database. So there's other tools that are maintaining circuit records. As endpoints move around, you have interface 1 fails, so you move the circuit over to interface 2, and then nobody remembers to go update the circuit diagram. But if you've got automation, this tool sort of covers that. And we focus on the human elements like layout, curves, aesthetics, all the fine-tuning stuff that makes it look and feel kind of cool. Under the hood, these really just get stored as structured JSON objects. So I just grabbed a blurb here from this example map. Some of the key elements that we're really focusing on right now is support for arbitrary metadata elements. This is useful for things like labeling, layout hints, and in particular, one of them, data targets, is really where we're mapping any data type onto the lines. And that's where things really start to get interesting. We can ingest this structured data into a variety of tools, obviously the mapping engines themselves, but we do a lot of monitoring of these maps as well, so that we know when things break, or we know when maybe some of the maps are starting to bit rot. So as the map tech evolved, so have the needs and usage of them. Most weather maps, when you think about it, are really layer 3 maps, maybe layer 2 maps if you want to be pedantic. And they're showing bits per second, and that's kind of the weather map that most people think about. But there's all kinds of different layers on your network, right? You might want a layer 1 map, and you're not showing bits per second there. It doesn't really apply. You're showing maybe DBM loss levels at the physical layer. Or maybe you want to show, I'll just key off of Andy's presentation, a map representation of like your perfSONAR data, right? It might be easier to correlate a problem if you've got a picture to look at, right? than a bunch of results. And who your audience is matters a lot too, right? When the CEO is looking at a map, it's probably a different use case than the network engineers. They don't need the same level of detail. And so what about all the other data that we're collecting here? We've got alarms, we've got maintenances, we've got CPU usage, we've got weather data. How do we incorporate all of these today? But at the end of the day, we're all still focused on showing one network, right? And what about other networks? So networks don't exist in a vacuum, right? By definition, they interconnect with other networks. That's, you know, how the cat videos flow. So if we show these maps one by one, you know, it's useful for highlighting that network. And that can be really useful if that's really what you're trying to do, or you're trying to troubleshoot some localized problem. But frequently problems are not localized, right? They are related to the rest of the community. So for example, where do these networks interconnect? How fast are they? How much capacity is in use on these networks where my traffic might be flowing? A question in this community might be, what transatlantic links are down right now that might be affecting some of my users? You might not have immediate access to that. And these are the sorts of questions that we were thinking about. How do we showcase more of this information? We already have a lot of maps that cover all of this, but we haven't really addressed this problem of a bigger view. And so what we did, and here we go, I promise we got to it, we created this application called Global Research Map as an extension on top of this already existing map work. So the idea here is that this lets us show any number of maps and help build the bigger picture, if you will, for RNA networking. With approval from networks, of course. We didn't just throw people onto this map without telling them. If you want to check it out yourself, here's the link. It's also, of course, in the slides. And the goal here is that, you know, we would be able to have kind of one-stop shop for seeing all of the networks, either in groups or one by one, including things like branding, snippets, links out to home pages, etc., where one of the main goals of this sort of thing is simply raising awareness of the community, right? You might not be aware of what networks are even out there. And so it's a great way to get yourself sort of on the front page, quote unquote. So I just grabbed a couple of screen caps. So this one, you got to know, again, I'm focusing on my immediate area. It's what I'm most familiar with. I'm not sure if folks can see my mouse or not. I'll assume that you can. So we've got over here the Indiana Gigapop network. This is what connects. This is the state of Indiana over here. And it connects up to Internet 2, which is all of these other links, right over here in Chicago, right? So we get a good sense of what traffic values are looking like at any of those times. We've also got, for example, here are a number, at least the ones that we're able to instrument, of the transatlantic links along with their real-time stats. It looks like one of these links, I happen to know the legend, is pretty unused right now. So if you were looking to get maybe some bandwidth or rebalance things, it's pretty easy to take a look at that and see what's going on. And it provides, like I said, multiple views in one place. So here there's a link, I believe this is a Canary link that goes over to Netherlight. There's circuits that go over from Manlan over to places like London and Paris, you know, where they connect up to GÉANT. And so instead of having a bunch of different maps in a bunch of different places where you can kind of see this, it's helpful sometimes to get one big view. I wasn't able to capture it live, unfortunately, but it's always fascinating when one of these goes down because you can see sort of the traffic on the other ones pick up as a result. I didn't think it'd be appropriate if I went into one of those routers and shut down one of the links. All right, so that brings us to community metrics, and as an extension, a little bit of the global research map work here. So we started this in 2019, just in time to sort of get screwed over by COVID. This is a collaboration between GlobalNOC, Internet 2, and the University of Utah to do what we've been calling community metrics. The focus has been reaching out to networks in the community to see if they're willing to share SNMP level information for the sake of transparency, collaboration, and like I said earlier, awareness of what's going on in the community. This data is stored in a GlobalNOC managed data repository. It's hosted by Internet 2. The goal has always been to make this as lightweight as possible. So basically, you know, in the optimal case, you might give us maybe polar access to a device, and you know, you wouldn't have to do anything else after that. There's other options like, you know, running a Docker container that feeds it back as well. All this data is available via APIs, and it's integrated into applications such as Global Research Map, and another one that I can, if I've got time, I'll drop out and show real quick, called Augmented Traceroute. Just another way to take this data and show it in other ways. This is generally available to interested parties. I won't go through this too much. There could be a whole other presentation. There's just an API. So for example, I'm listing out every node that's participating right now. You can see we got a bunch of Learn, UEN, FRGP. These are all networks within the US. And it's got a high degree of selectability to it. So for example, I can just run queries. Is any node in Learn experiencing errors right now? Well, the answer is no, at least when I ran this query. So that's really kind of helpful for things that you can do. This is still going on, by the way. Reach out if you're interested. There's this not particularly readable URL. It'll be in the slides. If this is something that you're interested in getting your map added to this, or at least sharing the data, or just even want to talk about it, possible collaboration, you can reach out to us as well. So as far as next steps here, we'd like to continue to work on expanding the community metrics project. We've been focusing recently on the Quilt network here within the US, but we're absolutely interested in our international colleagues as well. Several of the community metrics editions have been international networks, so we're definitely not just focused on the US. We're continuing feature ads for the open source maps. We've got most recently, there's a Grafana plugin that showcases these maps as well, so we can use them all in a bunch of different cases, adding more support for more data types, things like that. I'm probably at time, so I'll just kind of skim through this really, really quickly here. There's a lot of things that are hard about this, right? Topology sharing is hard because most people don't have accurate network diagrams, actually, right? They've bit rot a little bit, and it takes some work, but you can get there. Data collection is particularly hard. I know everybody has talked about this here, but privacy concerns is the #1 issue, right? Some people won't even tell you like what interface names or IP addresses we're talking about. Some people will just let you take everything and anywhere in between. And that, if you haven't built an automation from the start, that's pretty hard too. There's other efforts within the space really quick. I know there's the GÉANT working group. They're a great set of folks. I've talked with them a little bit. I know they're working on some shared spaces here. The GlobalNOC solution was basically built on existing tech over the years. NetSage and Epic has been a great partner in this as well. They've been very synergistic with the types of data and outreach. And all the other presentations that I've watched so far at this event, I'm always thinking about possible future synergies and collaborations. I think we're all working towards a lot of the same efforts here. And the last bit is, I think maps are really useful. I don't mean to undersell these ever. The last point here is where I'll end. Basically, they synthesize a huge array of data sources down into just one picture, and I cannot overstate how valuable that kind of information is. So with that being said, thank you. I know this was a lot of information very quickly. I could probably talk for hours about this, but I won't. If you have any questions or you want to throw any rotten tomatoes, there's my contact information. And thank you very much for giving me the chance to speak here.
Thank you very much. Very, very, very useful presentation. So I suggest that we go for the last one. And you then just mentioned the privacy issues, and now we will have Andrew Cormack from GISC who will tell us exactly about that. So Andrew, can you please share your presentation and start?
Yeah, as I said in chat, after the last two, I've kind of repurposed these slides. It was going to be about GDPR and data sharing. You've done that. What I propose to talk about is my usual role as the representative of layers 4 to 8 in these events, and talk about how to talk to lawyers, which may be a scary prospect, but it's something that I think pretty much every talk has hinted at and perhaps not wanted to push that bruise. And what I'm suggesting as a way to talk to lawyers actually should be a really good way to talk to users who might be concerned, what are they doing with my, with information about me? And also possibly about partners. If you've got people you want data from who aren't sharing, maybe this would help with them as well. So I'm not aiming for much here, I'm being ambitious. So this, I'd suggest, is the lawyer's view of a telemetry record. Chatting to Tim and others in preparing for this, I don't think we resolved whether there is a generic name for my little blobs that I called here and there. What goes in those could be MAC addresses, it could be IPs, it could be CIDR blocks, it could be ASNs, it could be names of institutions, whatever. So there's a thingy at one end, there's a thingy at the other end, and there's some statistics in the middle. Is that personal data according to GDPR? If you ask a lawyer, they will say yes, if either of the thingies, so either here or there, can be used to single out an individual for separate treatment. You don't have to be able to identify them. Identifying them also makes it personal data. But if either of those blobs only contains one user, then it's probably personal data. The kicker is also unless you know it can't, or unless you can make a good argument that it can't. So the presumption is that any IP address is personal data. Any MAC address, personal data, CIDR blocks, ASN, we'll get to. So when you go and talk to lawyers, or before you go and talk to lawyers, don't go in with the mindset, and include me in the lawyers you might want to talk to, even though I did used to run the security team for GÉANT. Do not ask your lawyers, can we do X? Because they will just go back to that slide and say, it's personal data. Read the GDPR and come back. Believe me, having spent the last, 15 years looking at drafts of the damn thing, you don't want to do that. What you want to do is go to your lawyers and say, this is why we think what we want to do is okay. That limits their thinking. It limits their ability to panic. It gives them one thing to worry about. It shows that you've done a bit of thinking. This is good. And the sort of way to explain why something is okay is, here's my network or my data sharing view of the same telemetry record. So what's the benefit of doing this, of collecting it, of sharing it, of measuring it, whatever? What's the risk? Is it, they've all been mentioned, is it personal data? Is it information about an institution that's sensitive about how much Netflix traffic it gets? And what safeguards can we apply? Some of those safeguards may well mean we're not dealing with personal data at all, which, as I say, makes life about 100 pages easier. And the other thing I'd think about at this stage is, if we talked to this about network users, if we talk to this with network users, would they go, yeah, sure, or would they start getting antsy? So it's, I think, done right, it can be quite a good way of reassuring people as well that we're doing stuff that helps them to have a more reliable network. The sorts of safeguards you might look at, well, I've gone for a pain scale. I'm not sure how readable that is, so apologies, but the coloring on the scale is also why I have no GIST corporate image on this, because adding the GIST corporate image completely trashed the colors. If you just go and say, I want to do network telemetry, I'm giving that a pain level of 10 out of 10. I mean, arguably I'd give it 11 out of 10, but we'll give you 10 out of 10, because your lawyer will come back and say, what's the purpose? What's the lawful basis? What safeguards have you got? How is you supporting user rights? And how are you reporting this to regulators? And that's their starting point. So we don't want them to start thinking about that. Whoops, sorry, wrong way on the mouse. One way to reduce the pain a little bit, but I'm only down to 8 here because I have spent the last 15 years doing this for incident response, is to say, for a single purpose, what happens? Here, I've got exactly the same requirements. I still have to have a purpose. I still have to have a lawful basis. I still have to have safeguards. I still have to support user rights and so on. But I've published, I think it must be now 30,000 words in law journals as to why this is okay. I was invited to present a virtual lunchtime talk to the European Commission in January 20, when did this damn lockdown start? 2020, that long ago. They wanted to understand what we were doing here, and they really like it. So it's possible, but I haven't got long enough for retirement to do it for network management. So I wouldn't pick that as my first choice. One that you can do in terms of purpose is picking out specific requests for help. So my gigabit flow isn't working. Fine. From my device to a server somewhere or to a network device somewhere, not working. Okay, to investigate that, I need to look at your traffic at individual personal data level. Is that okay? And I've given that a pain level of 2, because you might have to explain to the individual, okay, I'll look at it, I won't show it to anybody else, I'll delete it when we're done. But that's not too hard. It shouldn't be too hard. Actually, even easier, as mentioned already, perfSONAR. Active telemetry, where you're doing the measurement. 2 reasons I give this a 1. Firstly, it's not real traffic. So measuring the traffic doesn't disclose anything because it's only traffic. And by and large, you're going to specific beacons, dedicated, intended measurement points. If you start using perfSONAR or other tools to measure, individual home IP addresses, just don't, please. But active makes life really easy. Couple of things in between. I've put server in because I didn't have time to change the slide to say network device, because I suspect network device is what you're doing more often. So if you are measuring your telemetry between 2 network devices, you can flip a coin and say either this thing is a multi-user device, so I can't separate out individual users, or it's a 0-user device, so there are no users to separate out. But either way, picking the things that go in those 2 blobs on either side of the telemetry record can be very helpful. You do need to do a bit of effort here to justify your claim that that thing that I am reporting on has multiple users, but it shouldn't be too much. And actually the statement that a thing of this nature has multiple users should be pretty stable, I think. So once you've done it, I think you're probably okay, though do keep an eye on it. And the other one, rather than choosing endpoints, if you really don't want to choose endpoints, then again, it's been mentioned, aggregate data up. So how much you have to aggregate CIDR blocks, I don't know. I used to have a /28 at home. I don't imagine anybody is now handing out v4/28s to individual customers, but a /32 is definitely not enough. I'd probably raise an eyebrow at 28. At 24, I think you can make a pretty good case that it's highly unlikely that this is a single person, either on a domestic broadband kind of address allocation, or indeed an institutional thing. But this one, more so than the picking the endpoints, I've given it a slightly higher pain level of 5, because I think you do have to keep an eye on it. So you need to keep an eye on what are address allocation practices, address use practices, things like that, to maintain your claim that that you're not handling personal data. So finally, pick one of those, and these are some suggestions on the first document to write, or at least look and see if somebody's already done one. So if you're doing active measurement, active telemetry, define how you're doing it and what you're hitting it with. And from the sound of it and my knowledge of it, perfSONA's already got that for you. If you're doing specific debugging help, transparency statement to your user. A long time ago, I wrote a charter for system administrators on respecting user privacy, how much debugging you can do without having to go back and check. That's still up on our website and will remain. Actually, that one has moved. Sorry, our website is moving very, very slowly. Server telemetry, define how to measure the things, or network device, define how to select the things that you are measuring at. Rough guide in UK law is you want to be able to say there are, highly likely there are more than 20 people using this. And then any lawyer will go, oh yes, that's not data protection, that's freedom of information. Aggregation, statistical techniques, you have to keep an eye on risks of deaggregation. There's a really good network in the UK that do general anonymization research. And if you want to go with a limited purpose, then yeah, you do need to do the full legal analysis, and that will take you a while. So I think that's me. Oh, sorry, my clock has ticked over by 1. Apologies.
Thank you, Andrew. Okay, before we go into the discussion, I will just share one screen, and I would like to show you some of the next events that are being organized by GÉANT project and by our work package. These are the events that will happen in the next 2 months. There is a Campus Network Management as a Service event on May 4th, and all these events, as you can see, are you can see them at the events page of GÉANT. So there is this CNAS event on May 4th. There is SIGNOC, which is going to be in GÉANT offices in Cambridge on 10th and 11th of May. Then SIGNGN, which is an online event on May 23rd. Then third European perfSONAR user workshop on 24th and 25th of May. Then next STF on June the 7th. Then there is TNC 22, and finally GNAG community meeting. So if you're interested in any of these events, with the last 2 being events which will happen in Trieste in Italy, you can find more information about these events at the GÉANT's events page, and you can register if you are interested in any of the topics that you can find over there. So I will stop sharing this screen, and I will use the opportunity to ask my first question as someone who is hosting this session. I was inspired by the first presentation, and this is when this question came to my mind. I was also people within the project know that I've been quoting Andy Lake and his presentation from the last workshop that we had, when he said, with the data, we would like to tell some stories. And for the researchers to be able to use the data that the androids are sharing and to tell some stories, I'm afraid that just sharing data is not sufficient. This is something that we've seen with the PMP, which is basically a mesh of perfSONAR-based nodes, where we have a lot of historical data. And if someone who is a researcher has a lot of data and not any other information about what is happening in the network, he's not able to do a lot and not able to tell a lot. Maybe he can spot some trends over the long periods of time. But my question is whether, and this is a question for RMP, whether they've been thinking about that, but also for other entrants, if there are some people who are from the operations or from the entrant management, have you been thinking, in case that you are willing to share the data with the researchers and to offer them the access to data, to provide also a list of some specific events that happened in your network? For example, fiber cut, DDoS attack that happened in the period between that and that time. Because this is the way they would be able to actually tell some stories and to see, for example, whether some changes in the latency, in jitter, in throughput measurements, in trace route, whatever kind of data you're offering, they would then be able to take something and to be able to compare their results with some specific event in the network. I know that this is also revealing some data from the network, and especially in case of some attacks or some problems with the network, maybe some managers are reluctant to share this data because this might present also reputation risk. But I was just wondering whether you've been thinking about sharing this type of data in this way, have maybe even a tighter relationship with the researchers who would be able then to send you back some of their findings and provide you a way how to look at the data in a different way and to have better monitoring of your infrastructure.
So maybe I can try to comment a little bit. So actually right now we have a lot of coinciding events that are trying to drive this initiative that we're working on. And there are mainly many deadlocks that are trying to solve in the same time. So trying to get some leverage to maybe unlock this initiative. So mainly we have some great research opportunities. We have a group that worked with a private sector network operator in Brazil, Team Telecom, and they got mobile data to try to see COVID mobility, and they could do that under an NDA. So they actually proposed us to do something similar, not related to mobility, but actually trying to infer quality of experience based on flow data, so that we can put perfSONAR probes inside every university of 1,500 universities in Brazil. So being able to infer quality of experience with real data is much better than trying to put a probe everywhere. But also we have a base of some probes in kind of 100 universities that we could try to see if getting this, I'll say, NDA approved flow data in an internal project with research opportunity, and also having this data share initiative to try to resolve a research challenge and operation challenge at the same time. So this kind of way to align different motivations for internal teams to share data, for external team to work together for RNP to solve RNP problem, and trying to create an initial success, research success and operation sharing success, and based on that, try to see how can we replicate that with low cost. So this is our initial idea for these. Are not funding, but we are committing our human resources effort to this internal, and also funding a project of a well-known successful research to be spin-off into RNP data. So this is our, we are hoping to have more success to be partial, but this is our idea to try to, as I said, to centralize all these motivations and try to find success in collaborations.
Thank you, Marcus. Any other comment about that, about some potential tagging of specific events that would help researchers actually to use the data?
Perhaps I can comment, Otto from SIKT.
Okay, Otto, and then we will have Professor Magdalena. I see his hand.
Okay, sorry.
So please, Otto,
I'll be quick.
Okay.
Working for an operator, and I also have my university hat on sometimes. It seems to be also a question of resources. I mean, mentioned, so who puts in the effort to prepare these tags, to dig through the data sets and make it available? So my impression is that an operator say, fair enough, we can probably provide it, but we don't have time to sort of prepare the data to share them.
Yeah, this is definitely the issue. But I was thinking about something a bit simpler. For example, let's say an enroller can say on March 13 between 8 and 10 a.m. we had an issue. So take a look at this specific time window and see if you can find anything in the data. If you don't have even this, then you're just looking at some a huge amount of data, some historical data about where you see some latencies, jitters, whatever, and that's I don't know what you can conclude from that. I know that there are some methodologies like unsupervised learning where you can classify and find some anomalies and some clusters of specific behavior, but I'm not sure even if you find this, how you can use this information. But okay, thank you anyway. Professor Maglaris.
Yes, thank you, Pavle. Well, I was very much intrigued by all the talks that we heard, especially the last session. And I wanted to ask those folks about this privacy awareness and about the risk of sharing data sets and so forth. I mean, we've been working recently in my university at the National Technical University of Athens with something that we found quite intriguing, and that has to do with federated learning, because you do monitoring, you assemble data and so forth. Each domain in a collaborative environment has its own data. There is a risk of sharing these data sets. And instead of that, I mean, in something called federated learning, you just employ the data sets in order to come up with models of machine learning models within your own environment. and you don't share the data with other environments, with other collaborators. You just share the models, and those models have been averaged out by some third trusted party, GÉANT or whatever, and then everybody is following up this shared averaged data model. I'm sorry, machine learning model. And is that a way that we could guarantee GDPR abidance and so forth, and still have some collaborative environment in a federated model?
And I've stuck my hand up to answer that one.
Yeah.
I think a lot of these things are overcomplicating. You know, GDPR lets the first, I've got it somewhere. The first sentence of GDPR says to protect personal data and to encourage its sharing, or words to that effect. Protection of natural persons with regard to the processing of personal data and on the free movement of such data. So whatever technology you use, I think the starting point is, why are we doing this? What benefit comes out of it? What risk does it create? And how can we reduce the risk, enhance the benefit to the point where it becomes a no-brainer? And that's very much the approach I'd start with. If you then discover, okay, this stuff is just too sensitive, you know, maybe your federated learning is on a controversial subject that individual students will just be more sensitive about. You know, in the UK, we're getting all sorts of horrendous stuff around, you know, even a course on the history of slavery is highly contentious in the national newspapers. So, you know, I'd start from the idea that we want the benefit that we want to get, and then say, okay, how far do we have to reduce the risk to make that benefit acceptable? That may involve technology, it may involve NDAs, it may involve contracts. Don't immediately jump to technology, because you may well be ruling out a lot of simpler, cheaper options that actually allow you to share more data.
Okay, thank you. Do we have any other question or comment from the audience?
We've focused quite a lot on GDPR concerns. I was very interested by Dan's talk about the GlobalNOC and the mapping. Some NRENs are happy to show live weather maps, others less so. I think there are other concerns, for example, around security. I know the GISC security division is nervous about putting active weather maps live, because it's potentially something that could be used by people looking at the effects of DDoS, for example. So I think there are other things other than GDPR that are potential concerns about sharing data and making data more widely available. And I just wonder what the thoughts around that are, how we might ease the concerns of our friends in the security departments and be able to share that sort of information. Or is that always going to be a problem?
Rick, do you want to comment on this? Tim has just asked, or
no? It was unrelated. I just wanted to state that GÉANT has a resource available for looking at slightly anonymized NetFlow data from the GÉANT network. There are tools that are readily available that we ran them through our GDPR and security folks to make available to researchers. And on V4 traffic, we essentially anonymize on the last octet of the traffic to ensure that it's not identifiable to an individual, and that's been deemed as good enough to be valuable data for the researchers and not susceptible to any GDPR issues. So if there's anybody who's interested in getting access to that data, we have a scalable solution in place to allow access to that. Please get in touch.
And is it publicly available, this access to the data, or? Not
publicly available, but readily available. it's behind. We want to make sure that it's only researchers that are accessing this data. So we require that you set up an SSH tunnel with the server that's holding this anonymized data. So like I said, get in touch, and we can give anybody who legitimately can get value from this data and is within the RNE community, and we will grant that access.
Thank you, Rick. Andrew, you raised.
Yeah, I was going back to Tim's, and certainly one concern when I was running the security team was that people would try and attack the network and then use the monitoring tools to see whether their attack had been successful. So whether you could do something like, I know, well, at one stage, though they seem, I can't work out whether they've turned it off, you could provide delayed information public, and then if anybody actually wants real time, go through the sort of process that Rick's talked about, that you need to have some confidence that they're on our side, not on the bad guys. But the major lot of, well, no, I think most of the DDoS attacks that we've seen, the bad guys are very clearly testing, have they succeeded in taking their target off the network? And if the network monitoring makes that even easier for them, that's probably something that would make the team quite nervous. But time delay might be something to discuss. Again, as in mine, it's you try and think of ways that you could address their problems rather than them coming back or leaving the field open for them to tell you just how wrong you are. I think is a much get on the front foot. I think it's a better way to start the discussion.
Yeah, I would say also that when you share some data, there is also reputation risk for the institution, because then it might reveal what are people doing when they're using your network, and how public money is spent for example, visits to Pornhub and similar sites, which is certainly not something that you would like to advertise to everybody. But yeah, there is this issue also.
Yeah, for many years, there was an annual survey done by one of the student newspapers where they sent round to every university just a list of IP addresses and said, tell us what how much traffic is going to this IP address. Level 0 was to answer it, which was not good. Level 1 was to look at what the IP address was, which was possibly even worse. But after a while, I explained to people about text-based browsers that are much safer ways of visiting sites where somebody's just sent you an IP address.
Thank you. Mauro, I see your hand.
Just a comment. I think that there is a difference in the use of these tools and telemetry, specifically about the use from the backbones of the providers and the use from a end user itself. I think that the privacy and most of the issues of the privacy pertains to the use of the backbone, in the sense that if I am my own sender of telemetry data and I'm collecting my own telemetry data, then probably that's almost hassle-free, as Andrew has clearly shown in his graph. But I'm thinking that we have to say that the tool itself can be used in these two different areas. And the main point is how much information should the backbone collect in respect to what the application should collect. In my opinion, these may differentiate and help us understanding the use cases in which these tools can be useful. As an example, should the backbone collect the data to analyze videos and other things, or should the application that is streaming video in real time and checking, should that specific application should use telemetry data and then check of its performance? I think this relates to the use of data and the use of who is using the data. And it might be easier to just let the application in some cases to collect the information and giving them access to a certain pool of information which is clearly public, or let's say average it over the general internet. But that's my food for thought, if you want, that what I got out of this discussion. Maybe I'm wrong, please comment.
Thank you, Mauro. Any other comments or thoughts?
I think going back to what Andrew presented, I like the way, or the proposal to take a more positive view of we would like to do X, and for reasons Y and Z, we believe this will be okay, rather than asking if we can do that. I think that's one valuable lesson to take away from today. But maybe if we can identify common use cases for which we wish to share data, then we can almost come up with a template of that, saying we would like to share our data for this purpose, and we believe this is okay because X, Y, Z. And maybe that will help us as we each try to share data between ourselves. And maybe, I don't know whether lawyers are the same the world around, but hopefully they share some common principles, and taking that sort of approach might work. And when people think that's a useful thing to be collaborating on.
It's certainly a lot cheaper if you're paying them.
I know your rates are good, Andrew. So.
No, well, I'm both, because I'm the lawyer that would like to be asked those questions, but then when I go and talk to real lawyers, I very much do it that way around. And I gather that on one occasion, a previous employer had budgeted, I think it was 10K for a bit of legal advice, and I went, can I rewrite the brief? So I rewrote the brief, and we ended up being billed 500. Just because I'd spent 2 days working out, or no, in 2 days, working out what the actual key question was, and only asking that. Don't pay lawyers to think and research on your bill. But I think, most of them are much, the good ones should be about finding a way to solve a problem. And if you can demonstrate that you understand that and you have a clear problem in mind, then I think there's a much more positive engagement possible there.
It makes me wonder whether, there's lots of task forces and SIGs around. Do the legal departments of NRENs speak to each other that much in terms of trying to work in common ways? Obviously, a number of them follow common laws because of GDPR and so on, but do they actually share practical ways that they can work together and be efficient with?
I think we've had 4 goes at setting up that task force, and it has, well, I think it's only twice got beyond the mailing list, and the most recent of those, which was the most successful, lost interest once GDPR had come into force, sadly. And I think there were only about 4 networks that were still interested, and I was again wearing 2 hats because I was on the GÉANT community committee, and I had to go and say, look, I just don't think there's enough common interest in doing this to justify GÉANT spending its time on it. So yeah, I've tried, and other people have tried, and no.
Well, let's say hypothetically we want to work on exploring the ways that we can share this type of data in the way we've discussed today, and we're looking for common technical approaches, as that's part of it. I think in parallel, finding common ways in which the lawyers are also happy is a good thing to be doing, rather than asking for forgiveness later. So it would be nice to be able to do that and to work on both things in parallel.
It would, I agree. And I'm subject to availability. I'm happy to be involved as somebody with a bit of knowledge of both. I'm not a lawyer, I can't sign off anything. Just lawyers do give me a fairly broad margin. I don't know that there's any shared working group, and at least one of the suggestions came down from the GÉANT, the directors group said, there should be a legal task force, and we went, yeah, fine. So can you send your legal people to one place? And nobody turned up. So.
Well, I noticed it, I forget who mentioned it earlier, there's a network performance working group as part of Internet 2, and they did come up with essentially a memorandum of understanding by which the regional networks could share data between each other. I don't know how far that got. There was certainly a draft document online that I saw, and maybe that type of approach might be a stepping stone.
Yep.
Do we have any other questions or comments?
I think we come back to the question I posed in this morning's session, is what people here think the GÉANT project might be able to do through some collaborative action there. There have been some things proposed. There is still, what month is it? There are still 8 months left in the current GÉANT project, and there is another 2-year project following on. Are there specific technical or other things that the audience here thinks the project could work on? Maybe try and redirect a bit of underspend towards to get some useful, tangible benefits and outputs. Any thoughts on that? Frederick.
I'm not sure if this is relevant, but I don't remember exactly when, in which presentation it was referred, but it was referring to how to share topology and how tedious it was to retrieve this topology from the network backbone. And not sure if you remember, but for those who were here back in 2017, we were talking about a topology service within perfSONAR that would work in parallel with the lookup service. And for each research project, we will identify which which portion of the technology could be shared. And at that time, it was really hard to have all the topology built by hand. But these days, we have tools such as, not tools, but standards, such as BGPLS, who is widely available. And from this starting point, we can also benefit from various networks who have orchestrator and automation in place, so that this topology service can be, I would say, have a new incarnation with the new technologies. So if it is something that is valuable for you, but based on the fact that, for example, ESnet or SURF are using automation and have pushed the orchestration concept at the high level, I'm not sure maybe if this is something it's worth to investigate.
Essentially, underneath those, there should be sources of truth that have that information that could then be exchanged. But I think the driver for perfSONAR was, and maybe I think it was Mark Vate's work on, he had something called P-Shooter. And the idea was when you're trying to troubleshoot end to end, if you can deduce where there are perfSONAR nodes on the path and you know the topology, then you can test between those nodes along the path to home in on where the issue is and try and do that as automatically as possible. But we also know from the presentation on Microdep that doing that sort of activity, you can deduce and build not topology maps, but certainly maps of which routers are connected to which routers through all the trace routes. But that doesn't necessarily tell you anything about the physical links underneath them or much about them. But it's a good question. But again, the concern there may be about sharing topology is giving potentially attackers information about the structure of your network. It's not so much GDPR and personal information, it's more of a security concern from that perspective, maybe.
Okay, I see no hands, but for the last time, is there anyone who would like to ask something or to comment? If not, then we can end this workshop. And on behalf of the organizers, Xavier, Mauro, Ivana, Tim, and me. I would like to thank all the presenters. And also I would like to thank all the participants of this workshop. We had more than 70 persons from 20 different institutions. I think this was a successful one, and we had a bunch of very interesting presentations. We will, again, like the last time, it was recorded, and we will convert this recording into a YouTube video, so you will get an information about that, and this information is going to be put on the Indico page. So thank you all. I see some last comments. The comment from Professor Magler is about federated learning, and yeah.
Yeah, if you've got anything you think of just as the call ends, then do feel free to email us.